In this series, you'll learn React from complete zero without any experience. We will start with why React even exists, and then we'll build up through components, props, state, hooks, and more, all by building one real application by the end of this series piece by piece. First up, in this video, we're going to learn why React beats plain JavaScript. Let's go.
Okay, so in this section, we're going to be making a counter app, right? So we're going to be making a counter application. And what we can do is we can assume that we will have a screen. And inside the screen, we will have a text that says, for example, like counter. And we will have a variable that will increase. So for example, for now, this is 0. And it will go from 0, 1, 2, 3, and so on and so forth. So this is what we'll be making in the first section. There's two ways to do this. One is using JavaScript. So this page itself is going to be made using HTML, and I'm assuming you know a bit of the basics of HTML. Don't worry, we'll go through this as well, so if you don't know it at all, we will do this. And JavaScript is generally what we use to add basic functionality to our web pages. But doing JavaScript, you have to do stuff like get document by ID, and we will look at this. So you have to manually reach in and change this counter from 0 to 1 to 2 to 3 to 4 manually every single time. Whereas we're going to do it using React as well. So we'll do both of these examples. And inside React, you just say, I want to change counter. And that's all you say pretty much. Now, obviously, you won't say it in plain English. You'll say it in a way that React will understand it. But all of this manual changing that we did in here, React is going to automatically handle that for us. So we never actually have to reach into the code ourselves. React automatically reaches into the code for us and changes this counter variable. So all in all, we're going to have a page that's going to keep a count. So 1. And first of all, we're going to use JavaScript to achieve this, to increment this counter. And next we'll move on to React and compare these two. Alright, so I have IntelliJ WebStorm opened up right here. You can continue in VS Code as well. But you can get IntelliJ for free if you're a student, and even if you're not, then you can use it for a while on trial, long enough for you to be able to learn React fully. So you can follow along in VS Code as well if you please, but I simply made a folder and I'm going to create a new file, and I'm going to create a file, counter.html. So it's going to give me template boilerplate code. If you want to get this in VS Code, type an exclamation mark and then type tab or enter, and then it'll give you this boilerplate code, but I'll just leave it as is right here. Now I can view this by simply pressing on the run button, but in VS Code you can obviously download this extension that I'll have on the screen right now. Okay, so I will run a debug. I'll show it on my left side like so. All right, I'll be writing some code here and the code will be live updating on the left side. I might want to make that a little bit smaller. All right, inside my body, let's start with some code. All right, I'll simply create a h1 tag like so, and I'll say count is 0 for now. And if I refresh my page, I can see that it does say count is 0. That's all I want right now. And I want to be able to increase this count, right? Like I said before. So we'll add a button to do that. Let's add a button. So far, I'm doing just basic HTML and I'm going through it while explaining it to you so that you don't get lost. So I'm going to add a button and I'll just say add one. So I'll have a button that says add one, and currently clicking on it does nothing, well, because there's no functionality. Remember how we were going to use JavaScript to increase this? Yes. So when we click add one, we need to have some sort of JavaScript that is going to increase this count by 1. Now we could create an external script file and import it like so, but I'll just use my script right here. I'll just put in a script tag and I'll write my JavaScript right here. Also, if you're getting those annoying inline suggestions, go to settings, search for inline suggestions and turn it off. And once you turn it off, you'll still get your IntelliJ suggestions on methods, but you won't get the AI ones. Now, all we want to do, so every time, if you notice, I'm adding my script tag after the body. So I want my script to only load after my entire body has loaded. This makes your website more performance effective. Okay, inside my script tag, I want to get this button. And whenever this button is clicked, I want to increase this by 1. The way we're going to do that is we're going to give these elements IDs of their own so that we know what button is and we know what H1 is. So H1 is going to get an ID, and let's say I'll give it a name of display. And button is also going to get an ID, let's say of the name add btn. So I can get this button using add button, and I can get this element by using display. Now we're going to do exactly that. By default, we need a count variable, right? So by default, let's say let count equals to 0. We're just creating a variable called count and setting it to 0. So this will be representing what value we're going to put in here. Next, we need to get these two things. So we need to know where we're going to update, and we need to know what we're going to use to update. So we're going to use const display. I'm going to create a const display, and I'm going to set it to document.getElement. And the ID that I want is display. And next, I want a const button, which will be document.getElement by ID add button. So I have my display and I have my button. Next, I'm going to add something called an event listener. So you know about events, right? Anything that happens is an event. If you walk, that's an event. If you press a button, that's an event. If you're looking at something, that's an event, right? Just even in normal English sense, event should make sense. Event listener is just something, or in this case, a function or a method that we're going to attach to this button, and it's going to trigger every time we click the button. So right now, nothing's happening when we click the button, but once we add an event listener, every time we click a button, it'll be like, oh, the button got pressed, I need to do something. So let's add an event listener. The way you do that is you want the actual reference to the button, which we've stored right here. So we're going to do button.add event listener. And we're going to add event listener. What event are we going to look for? So we're going to look for the click event. There's a lot of events that can happen, right? But with a button, we want to look for the click event. And once we're clicking on the button, what do we want to do? Well, all we want to do is we want to increase this count by 1. And we want to increase the count right here by 1. So the way you do that is you pass in a function. Now, I'm sure you're pretty familiar with function. It's just a block of code. So once we get that click, we're going to execute a function. So I'm going to write a function. And inside this function, I'm going to increase the value of count. So count plus equals to 1, which is a shorthand syntax for increasing this value by 1. If this was 2, it would become 3. If this was 3, it would become 4. Since it's 0 right now, it would become 1 for the first time. Next, display. So I'm going to get my ID of my heading element, and I'm going to do display dot text content. So every bit of text inside this, which is basically count is 0. I'm getting that, and I'm going to set it to count is not comma plus count. So by default, our count is 0. Right here also we have 0. But once we press the button, so we have our button right here, we're adding an event listener looking for click. Once we press the button, this function gets executed. This function is going to increase the count by 1. So it's going to increase this local variable y1. And display.text content, as in this element, and the text content is in here. This text content is going to get replaced by count is and the value of our count variable. Now we can save this and we can try it out. So to try it out, simply just press the button. So I get count is 1, count is 2, 3, 4, and as long as I press this button, the local variable count, the value of this variable, is increasing. And simply in this text, we're just showing the value of that variable. That's all we're doing. And to do this in JavaScript, so to make a simple counter application, I guess you could call it, in JavaScript is this much. Imagine you have a real application. A real application will probably show this count in more places than one, won't it? Right now, we're just showing how many times we've clicked the button in one place. But for example, if you were scrolling through your comments, there would be multiple ways to access your comments, not just the comment section. You could go to your profile and see your comments. Somebody else could go to their profile and see your comments. So you need to be able to access the same thing from multiple places. Let's try doing that with JavaScript first. Let's try adding a second place. So adding a second place that shows count. That's all we're doing right here. We're adding a second place that shows count. And I'm going to give a paragraph. And I'm going to say you have clicked 0 times. Also, I want to add another button. I want to add another button that instead of saying add one, it says reset. And I'll also give this the ID of reset. The way I copied that line down immediately was I pressed Alt, Shift, and down arrow, which immediately copies the line downwards. And if I want to move this line downwards without copying it, just simply hold Alt and you can move it down and up as you'd like. So right now, add one does increase this count, but it doesn't increase it here. Our reset button also doesn't clearly work right now. So let's add those functionalities. Well, for our paragraph, first of all, we need an ID to be able to select this. So I'll give it the ID of subtitle. And down here now, instead of just grabbing our display and grabbing our reset, we also have to grab our subtitle. So this element right here. And we have to know what our reset is. So let's come down here and let's create a const for reset button equals to document.getElement by ID reset. Let's actually name that reset button for uniformity, reset button. Next, we also need our subtitle. So const subtitle equals to document.getElement by ID subtitle. Now we have a reference to reset and subtitle. We're going to add an event listener to our reset the same way we added an event listener to our add one button. So when we clicked add one, our count would increase. When I press reset, I want it to set back to 0. This could be a fun challenge for you that you can figure out yourself. Since we're updating with the variable count and we're simply doing display.text content, you can do the same thing with reset to set this back to 0. I'll go ahead and do that now. Instead of button.addEventListener, I'm going to add an event listener to my reset button. Also, since we're using two buttons now, it would be more appropriate to call this the add button. So I'll change it right here, the add button. And that's much more appropriate so that I know what is what. It's just good coding principle. Then reset button dot add event listener. And again, I'm listening for an event where I click that button. Whenever I click that button, I want to execute something. So I want something to happen. And that something is I want to set the count back down to 0. Notice how I'm directly assigning it a value of 0. Right here, I was incrementing it. So the previous value would matter here. But here, the previous value doesn't matter. No matter what it is, I'll just set it back to 0. Right after I do that, I'm going to display.textContent equals to, and I'll do the same exact thing again. But instead, this time, the value of count has already been reset to 0, so it's going to reset. Now let's play this out. I'll keep on clicking add one, where my count keeps increasing. But as soon as I click on reset, the count goes back down to 0. But notice we still haven't touched our subtitles. Our subtitles still doesn't have this, you have clicked 0 times updating. Well, to update it, we'd also have to do subtitle.textContent equals to you have clicked count times. And you'd have to put this exact same thing inside your reset button as well. So every time we increase the count or change it, we're manually setting the text content for our heading. And again, we have to manually set our text content for subtitles. Even right here, every time we reset the count back down to 0, we manually have to reset our heading content, and we manually have to reset our subtitle content. Let's see if it works. We keep on clicking add one. It doesn't actually work right now because I haven't refreshed the page. So as soon as I refresh, you can see that both of these values start increasing. They both increase simultaneously. Now, obviously, there's no point in having this right below your header. You may have this on a different page, or you may have this multiple times in multiple different pages. Now, every time you needed to update this one variable, you'd have to manually go in and update wherever you've placed it in multiple different pages. That is where JavaScript gets messy. And that's where React helps us out, actually. And React is a counteracting way for that repetition and stopping your manual updating of your fields. All right, we're going to set up the same counter in React. This is a pretty quick no install version, so just so that you can see the app running, but we'll actually set up React properly in the next section. So I'm going to create a new HTML file and I'm going to name it React Counter. So you saw how we did it with JavaScript, and then we're going to look at how to do it with React. Now, generally, you'll set up React by downloading packages, setting up Node.js and stuff, but we're going to use CDN. So let me just comment it out somewhere in this document. So CDN, just so that you're not confused. So we're going to use something called a CDN. CDN is basically, it is a web address that loads ready-made code into our page. We're going to use it to pull React without installing anything. So that's the basic essence of a CDN. It's just a web address that loads ready-made code into our page, and we're going to use it to pull React without having to install React itself. Another term that will be coined in this section is called a component. So you know how functions work in JavaScript, right? Component is something similar. Component is a function that returns a piece of the screen, and its name always starts with a capital. So component is just a function like we have in JavaScript, and it's going to return a piece of the screen. Now I'm going to explain what a piece of the screen means, and you're also going to look at what a piece of the screen means, so don't get daunted right now. And just remember, whenever you're making a component, just start with capital letters. And the last thing I promise that we'll be doing in this section, talking about, will be JSX. Generally, we write HTML inside the HTML itself, right? So like we have counter.html right here. And all the HTML portion of this is inside the HTML itself. And inside the script portion, we have our JavaScript. But in React, you actually write the HTML portions inside JavaScript itself. So all of this HTML will actually live inside JavaScript. So we're going to use JSX to do that. And don't worry, I'll go very slow one by one. So JSX is basically the HTML looking code. So it's not HTML, it's just the HTML looking code that we get to write inside JavaScript. That is a very crude definition for now, but just understand that much for now. Now we can get started. All you have in your React itself, and as we move on, I'm going to explain everything that we use, but for right now, I just want you to copy and paste things that I write in here, just to see how a React version of that application looks like. You might not understand everything. I don't expect you to understand everything right away. I just want you to be able to follow along right now and just copy the code that I write out. Okay, so in my body, I'm going to have a div, and the div is going to have an ID of root. Now remember how we selected elements? We selected elements by giving them IDs. So we have just one element inside of React, and that element is root. Every time we want to put anything inside our page, we put it inside root itself. And we're going to do that and look at how that looks. That is our body. So at the start of our body. And now we're going to write some scripts. Notice that I started the script inside the body itself. That is because we want to load a few scripts that allows us to use React without having to install it. And I'm simply just going to copy paste these scripts in here. And you can follow along. The code for this is also in the GitHub repository, link in the description. So you can just follow along for now. So I've pasted down these 3 scripts. The first 2 loads React for us. And then the third one is a translator that converts our JSX into something that the browser understands. And now we actually start beginning to write the script for our React. I'm going to start a script, and the script is going to be of the type, text babel. So I'll explain what this is in a bit, but for now, just follow along. Inside our script, we're going to pull useState out of React. Now, every time you learn something new, you'll come across very new terms like useState, Babel, maybe even CDN, or this stuff is pretty new to you. But you have to take it slow, one at a time, and trust yourself that you can understand it. You'll get the syntax, you'll get the hang of the syntax slowly, but right now understand useState. useState is just how React remembers things. So where we use right here, we used count. This was the value that would change, and JavaScript itself would have to remember, or actually we would have to remember and then change it ourselves. But right here, we're going to use something called useState, and useState is how React keeps track of things that are going to change. Okay, so again, just follow along for now. So const useState equals to React. So we're just pulling useState out of React. Next, we're going to make a component. So I talked about components. A component is something right here. A component is a function that returns a piece of screen, right? It returns a piece of the screen. And component always has to start with a capital letter, always a capital letter. So the way we create a component, it's a function. So function counter. Counter is our component. And we're going to write inside this component. So we have a few things. We're going to have a few things inside this. First of all, we have our count. Count is the current number, right? And next thing, the way we're going to change our count is we're going to use set count. Set count is the only way, actually I'll write this in caps, only way to change count. Right here, we changed count by simply doing count plus equals to 1. Well, we can't do that here. We have to use set count to change that number. Okay, so you get the hang of components as well. For now, follow along. So you have count and you have set count, and they're going to be useState and with the argument of 0. Okay, don't worry about this right now. useState is what is going to let us, or how React remembers a value that is going to change. So this value is going to change. This is our value, and this is how we're going to change that value. useState is keeping track that it knows, so that React knows that count is going to change. So now right here, we're going to describe what the screen should look like. So we'll describe what the screen should look like. Basically, this is the part where we return our JSX, or where we return our HTML looking code. So inside here, I'm going to return, and I'm going to return a div. And inside this div, what did we have earlier? We had our h1 tag, which said count is, and let's say 0 for now. Next, what did we have? We had a p tag that said you have clicked 0 times. And right after that, we had 2 buttons, right? We had a button that said add 1, and we had another button that said reset. So we're going to modify these elements so that they themselves will handle all of the logic for us. Inside here, we had to make the element. We had to grab that element. We had to add an event listener to a button and change that element when that event was pressed. That is a pretty long process. But right here, we're using useState to keep track of things we're going to change. We say that we're going to change count, and we're going to use set count to change it. We're going to look at that briefly. and we're just returning a div of the entire HTML. Now inside h1 tag itself, instead of just saying count is 0, you can directly place in count. So I can directly just put in the value of count. Whatever the value of count is. Currently count is, well, nothing, because count hasn't been described yet. It's 0. So count just gets placed immediately by its own. And even here, you can simply just give in count immediately. So part of our problem is already fixed. It's kind of dynamic, and we'll see how it's dynamic instead of hard coding 0 and then manually changing the entire sentence. So changing the entire sentence, we just directly inserted the value of count inside this element. Okay, but what about changing the value of this count? We had to change it when we pressed add 1 and when we pressed reset. Well, to change it, we added event listeners before, but I said at this point, I said we have to use set count to change count. Set count is the only way to change count. So what we're going to do is inside button, we're going to check if we've clicked the button. So it's basically an inline event listener. So on click, once we click the button, I want to do something. And what I want to do is I want to set count plus 1. That should be pretty self-explanatory. When we click the button, we're going to do set count plus 1. And don't be scared of all these curly braces and brackets and everything. I'm going to explain all of this. I'm going to explain what these brackets on the left do and why we have these brackets and everything. I just want you to understand the logic for now, okay? And what do you think we would do on reset? On reset, we would do on click, simple. We're going to do, yes, set count, as simple as that. We have our count and set count. Set count is going to change the value of this count. We can use count directly inside our elements. And inside our buttons, we can directly change the value of that count when we click the button. We don't have to grab elements and manually replace things by ourselves. Everywhere that we want to use the count, we just put in this. We don't have to create a new element and then grab it and then change it. We don't have to touch the element at all. These two buttons will change the value of count, and anywhere we want to use it, we'll just put this. And right after the curly braces right here, so right after our curly braces for our counter component, so right after our counter component ends, we actually have to render it onto our screen. So remember, our box was div. We have our div right here. If we typed in something, and if we went to our page, this something would load. We're putting stuff into this div. So we have to actually put in everything. So everything that this component returned, the component returned us with this beautiful HTML. So you have to put this HTML inside our div for it to show on our browser. And we're going to do that right here. Simply before your script tag, after this curly braces, we're going to add it. So we're going to find root. We have to do it only once. Remember here, you have to do it every single time you wanted to add anything to your screen. But here, this line will only ever come once. If you have one element, if you have 100 elements, or if you have 1,000,000 elements. So const root equals to react dom dot create root document dot get element by id root. We will go through the syntax, but we're going to use React DOM to create a new root, and then the root is the element that we pass in right here, the element that we got on the top, so that React knows where the root is. And at the end, we just do root.render. So now that we have our root, we can render any component inside it. So this makes sense now. Component is a function that returns a piece of the screen. Component is just a piece of the screen. The entire screen is root. And when we do root.render, we can render different components to build up our screen. So we might have a counter component right here. We might have a clock component right here. And we're just going to use root to render our counter, our clock one by one. So right now I want to render my counter. So I'm going to do root.render. And then the syntax is like this. You do this. This is your syntax. And you'll get used to this code, so I'll full screen this right now, temporarily. So you'll get used to coding in React like this. Obviously, you won't have these because we will set up React properly. So the counter HTML, just for reference, the counter HTML that we got from our JavaScript looks like this. You can add stuff and you can reset. And then the functionality for that was all done right here. But every time we want to add a new element, we'd have to add it here. We have to grab that element and we have to change it in our add event listener manually every single time. If you have 1,000 elements, well, you need to change it 1,000 times. In our React counter, however, now all we did was this many lines of code, so not that much actually. This was around 41 lines and this is around 47 lines. The only reason why this is slightly longer is also because we have around 1, 2, 3, 4, 5, 6, 7, 8 lines of imports. So when we execute this, or when I click that debug, we can see that it looks pretty damn similar. So if I move it a bit here, it is almost identical. We can click add one and our count is automatically updated in both places this time because both places use the actual variable count, and we're just changing the value of that variable using set count inside these buttons. So if I wanted to add another paragraph tag, so button has been clicked count times. If I wanted to add another paragraph tag like that, inside JavaScript, I would add a paragraph tag here. I would grab that paragraph tag by ID, and I would change that paragraph's text inside this event listener, and I would change it inside this event listener. But right here, all I have to do is literally just add it here. And now, when I refresh, I should see that that field pops up, and guess what? It works perfectly fine as intended because it pulls this local variable by itself. And the reset resets all three of them properly. So don't worry about how we use useState right now, or don't worry about these arrows right here that might be a little bit daunting for now. We'll explain all of those slowly, perfectly, pace by pace over the next chapters. Right now, just feel the difference. Okay, so right now we have a web page, and this web page is getting rendered onto our browser. And currently, this is just one counter.html file. And this is a single file that is getting rendered onto our browser to show our counter. But real applications have multiple files like these, like multiple hundreds, maybe even thousands of files like these. Now, it is difficult to keep track of all of this and also render them onto our browser at the same time manually. So we have a shortcut for that. We have a bunch of files, and these are a bunch of files that we want to render onto our screen. Last time we ran these files with a bunch of CDN links. So basically just pulled them from the web and made them run temporarily. That's okay for a tiny demo, but real apps have a lot of these files and all of them use JSX, and you have to be able to handle all of this JSX everywhere. Remember, JSX is HTML looking syntax that we use inside JavaScript. Now we need a tool. That can take all of our files, bundle them into a neat little box, and ship it off to our browser. And that is exactly what Vite is. So think of Vite as our workshop. We don't know what is inside it, and we actually won't go through what's inside Vite either. We just know how to start Vite. We use 3 commands. Literally, we use 3 commands to start up Vite. What you have to take away from this section is Vite is going to take all of our packages or all of our files and all of our JSX and handle them for us and directly show them on the screen so that we don't have to manually worry about all of it. Vite is our workshop. So we've talked about JavaScript and we've talked about React a little bit, But Node.js, so this environment, lets JavaScript run on your computer. Natively, JavaScript runs on your browser, right? We know this. But Node lets JavaScript run, well, everywhere. So it runs in your command line, it can run in your operating system, it doesn't have to run on your browser. The reason why we need it is because React is dependent on it. We get something called NPM. So let me Google that up for you. NPM is also called the Node Package Manager. Node Package Manager, its job is basically going to download a bunch of code that other people have written. So very smart, very talented people have written a bunch of code, and you can import that code and then use it for your own so that we don't have to rebuild everything ourselves. So okay, come on to Node.js and click on Get Node.js and download the Windows installer for this. Make sure you're downloading the long-term support version, not the EOL or current, and download it. You can download it using Docker as well with NPM if you're using that, or you can download it on Linux using NPM, and if you're on Mac, you can do such as well. Or you can get a pre-built Node.js version for your Linux, so as a binary, for macOS as your PKG file, and for Windows as your MSI file. And just follow along with the instructions, click next, 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 install, and then finish. So once you're done, simply open up your terminal, just a PowerShell or command prompt, and then type in node-v. And this should print out the current Node version that you have installed on your system. It seems like I don't have the latest version, but you should have a version installed that is later than 24.14 or equal to this. And you can also check your NPM version, so npm-v. You'll get something like 11.17 at the time of recording. And if you see numbers, you're all set. If it says command not found, just restart your terminal or restart your device and then try again. So open up your PowerShell once you're done with that. And I'm going to cd into my desktop. We're going to create our Vite, the project generator, and we're going to create our app, which is study deck that you saw at the very beginning with our template of React. So npm create Vite@latest. And our project name is study deck. And we're going to give template as React. And as soon as you click enter, npm will start installing stuff and do it all for you. So it might say need to install following packages. For the first time, just click enter or press Y, and it will start installing all of this. So it says select a framework right now. Just hit your down arrow a few times and select your React and click enter. And right here, you want to go down and select JavaScript and use ESLint instead of AuxLint. Just click no for now. Install with npm and start now, yes. So go ahead, you can see that we created a folder, and I'll open up the folder on the right, and it's going to set up our basic project for us. This is a development server, a little preview server running on your machine while you build. So this is just Vite's demo page. You can see this also has a counter right here, and if you click on it, the counter does go up. It's just a starter page that is slightly interactive just to make sure that Vite works. I'm going to start a new project. So I can open a project and I'm going to open that path. And I'll select this folder and I'll create it in this window and trust this project. So once we're in here, you might get a README, but I'll simply just ignore that. And in the next section, we'll start touring out all of these files and see what they do. I'm going to demystify all of these files. So if you know what all of these files are, you can skip ahead to the next timestamp, but I'll just go over all of these folders. At the top, we have the .idea folder. So this is just a folder that's created by your IDE by default. We can ignore that. Next, you have your node modules. So if you look inside it, it's a pretty big folder with, you can see React in here, you can see Vite in here. So it's huge. It's automatically handled for you and you never have to touch this folder. Just know that all of your root library files, so everything that you're using is in here. Okay, next is our public folder. So inside public folder, you might see a few SVGs. So SVGs are basically image formats. Whatever you want rendered onto your page. So like if you want a photo, that photo is going to be the same no matter what, right? So anything static that you want on your page, you'll put inside the public folder. Next, we have our SRC folder, and this is where we're going to be working 99.9% of the time. You don't have to touch anything else, okay? So inside here, we have a few things. The first thing that I want you to look at is the main.jsx. This is the starting point of our application. So we'll go through what all of this means. We've done a little bit of this already. So we already did create root a little bit, and we also did document.getElement by id.root, and we also did .render, right? Then we have our index.css. This is just styling, ignore it for now. We have our app.jsx. So everything that you saw earlier, so the entire thing with the counter pages and everything, you can see the counter is right here. Count is count. They're doing the same thing. Look, they're doing set count and count number. They're increasing it by 1. So it's nothing that's brand new to us. Of course, it's pretty new because you've done this literally only once yet. But you can see we have count right here. We use set count. We used useState, and we did set count. We increased the value. We showed it on the screen like so. So we've done a little bit of this before. And this is basically the demo page that we saw earlier. So this is the code for that. We'll clear all of this out and write our own code. And app.css, so this is the styling for that page. Inside assets, you'll find different images. So different images that we use throughout the page. So a bunch of SVGs, a bunch of PNGs, and such. All right, that is our source folder, and that's where we'll be working on most of the time. Then we have our git ignore. This is a very important folder. This basically when we upload all of our files, GitHub using Git, we don't want to upload large files, right? So these are all the files that we don't want to upload. There might be some sensitive files that we don't want on the internet when you host your website. So these are those files. I won't go through auxlint. Let's look at index.html. This is your main HTML, by the way. This is where everything is. And you'll notice that inside here, we're loading in a script. And that script is actually what we just looked at. It's main.jsx. This is where we're doing everything. And this is the script that we're loading into our web page. And you'll also see this familiar div with the ID of root. So this is a container. This is a container that's on your page with the ID of root. Anything that we put inside this container is going to show in your page. So we're going to make things, we're going to make components, and we're going to put it on the screen by putting it inside this div. I hope that's a bit clear. We'll go over it again. Then we have our package.json, which basically has all of the essential knowledge about our application. So it has the name, it's private or not, it has our versions, it has all of our scripts, all of our dependencies, so React, and all of our dev dependencies, Vite, and everything. So everything that we're using is inside our package.json, and anybody can look at a package.json and be like, oh, they're building a React application with Vite. Then I won't go through package lock. A README file is default generated right here for you. You'll probably make your own README file after you make your own application though. And Vite config are just configurations for Vite, which we won't even touch right now. We'll leave it alone. So there's no more mystery folders. You should be slightly comfortable with most of what's going on in here. I'm sure you're overwhelmed if you're just coming from a non-technical background or just trying to learn all of this for the first time, but we'll go through over all of it again. So just making it a little bit less daunting for you. So we'll start little by little, changing all of this stuff to make it our own. But to do that, you actually have to see what's on the page, right? We looked at the page earlier, but how do you open it from inside all of this mess? So if you're in your VS Code, then you simply just want to open up your terminal. And the way you know how to run an application is to always look inside this package.json file, okay? Once you open the package.json file, you see a bunch of things. Don't be scared, don't be confused. Just go inside scripts. And inside scripts, you should have something that looks like this. So something with dev inside it should be fine. So In my IntelliJ, I just get a play button right here, but you don't have that in VS Code. So what you want to do is anything that's written right here. So it just says Vite, right? So I just want to run Vite in my terminal. If it says Vite build, I want to run Vite build, but that is for building. Right now, we just want to run dev because we're developers and we're running it in dev mode. So I'm going to copy this link and I'm going to open up Chrome and I will open up this link. Voila, I can see my page successfully now. Like I did before, I can see my page, the count is working, everything works fine. I can refresh it and everything works fine. Also, you can see that the title is actually the title that you give your project, study deck. That is something interesting. Okay, the first thing I want to do is get rid of all of this. I want to get rid of all of this and just put our text in here and see how we can change this stuff. Okay, what I told you was everything is inside index.html, right? So all of this is being made somewhere by a component and it is being put inside this div, which is rendering it on the page. So if you put anything inside this div and then refresh this page, you can see that it briefly flashes behind right here. It is actually being rendered on the page, but we're putting something else on top so we can't see our original text. But for a brief second while it reloads, you can see that it does come on the screen. So we're just putting stuff on the screen by selecting this ID root and then doing document.getElement by ID, you get it. And what starts our application? Well, it's main.jsx. So let's go inside main.jsx. What are we doing? We're creating a root. So we're creating a root for React. Root is where everything goes. Again, root is where everything goes. And we're selecting that element. So this element that we created right here in our index with the ID of root, we're selecting it by doing document.getElement by ID. And we've done this before. And then we're doing .render and we're rendering a bunch of stuff into it. Let's not worry about strict mode right now. Let's just look at what's being rendered. We're rendering app. In our earlier example, we were rendering our component, right? Our component was counter. We did the exact same thing, but we rendered counter. In here, we're doing the exact same thing, but we're rendering app. So app is a function that returns us with a JSX that gets rendered onto the page, and then you can see a website looking like thing right here. So where does app live? Well, you can see that we're importing app from somewhere. From this file right here. So control and click on this file and you can see that everything that is on this page is being loaded from this file right here. So if I change anything on this file, everything will be changed right here. Let's try to change this get started. So I wonder where get started is. I can press Control F and then find the get started. So it says it right there. And instead of get started, I want to do something else. I want to say study deck. And if I save this, as soon as I save it here, you can see that it changed right here. Because this is the component that main.jsx is rendering on to our index.html. And that index.html is being pushed to our browser. I hope that flow makes sense. You make components. Your main renders those components. Once they're rendered, you can see them where your div root is. So this whole thing is a div, and you can see it on your screen. So I'll repeat it throughout and throughout, but that is essentially what's it. So if I want to remove all of this and write my own custom code, what would I do? Well, I would do Control A and delete literally everything inside this file. And if I save it now, everything gets broken. Everything gets broken. This still seems to oddly work. It's probably being cached somewhere so that it doesn't completely break. Okay, so the cache disappeared. It completely breaks and it is empty. So let's start. Let's start by creating a component of our own. Again, a component is basically a function that returns a piece of the screen. A piece of the screen is basically something. We return an HTML that you can view on the screen. So we'll create a function app. So app is our component. We are creating a component called app. That is what we're doing. Pretty simple. Inside here, everything that we return is what shows on the screen. So if I put an HTML just out and about like this, actually it won't even let me do this, but if I forcefully put an HTML like this and say this is my heading and save this, none of it shows on our screen because we have to return that HTML. We have to return this specific thing for it to show on our screen. Okay, so we're going to return something. All of our logic will go on the top right here. Currently, we don't have that much logic, so we'll just put a return. And inside return, we have to return what we want to print out onto the screen. So I'll return a div, and inside this div, I'll have a h1 tag, which says study deck. That's all it says. And below that, I want a paragraph tag, and it'll say learn anything, one card at a time. So just my slogan. And this should be pretty simple. And you would expect if I save this, it would load onto the page. Well, it doesn't really work that way. We're missing one line of code, literally one line of code between this rendering on the page. In our main.jsx, we're importing app from app.jsx. We're importing something. So obviously, naturally, inside our app.jsx, we have to export something, right? Inside our app, we're exporting something. And in our main, we're importing something. That would make sense. Are we exporting anything here? We're not exporting anything. We're returning something from our function, which is not the same as exporting this function as a whole. And I'll stop referring to these as functions from now on. I'll say components, and I expect you to understand that they're functions. Okay, so we're going to export using default app. Now, if I save this file, and if I refresh it right here, you can see study deck, learn anything, one card at a time. All right, we made our own component. We added our own HTML inside the component, and we exported that component. Inside our main.jsx, we imported that component, and we got our root, which is in our index file, and we rendered our component. So we rendered our app inside that root. Don't worry about the strict mode for now. And in our index.html, we have this div root where the component got rendered. Right now, let's say, for example, we're not rendering anything. Let's say right here, I'll comment all of this out and we're not rendering anything. So if I save this and if I refresh this, nothing will be on the screen right here. I don't even want to import index.css. So I don't even want CSS right here. No styling, no background, nothing. And inside my index.html, I can manually add it as well. I can manually add all of these things, right? I can copy this and I can paste it in here because this is basically a div. And if I paste it in here, it should show on the page. And it does show on the page exactly the same way, by the way, just without CSS, but we can add CSS by ourselves. So this manual process of me going to app.jsx, copying all of this, and then pasting it inside our index.html is exactly what React does. And this is what you need to absolutely understand. So anything that we put inside a component gets rendered into our HTML like this, exactly like this, by main. So that's what main render is doing. I really wanted to show you this practically by doing it by hand. Please never do this in your React applications if you want a career in web development. So make sure that your root is just empty and anything that you're rendering onto here goes through main JSX first. Otherwise, it defeats the whole point, right? So if I refresh this now, you can see it got styling because we're importing CSS. If we actually just went to our index.css and removed all of this, the styling would go away again. It just came with a bunch of default styling. And we'll make our own styling too, so don't worry about that. But that was, hopefully, you understood a little bit about components, and hopefully you understood a little bit about how React actually puts things onto the screen. We got this so far, but I want you to be able to create your own components and then use them in your website. So for this section, I'm going to teach you how to make components. Please pay close attention. Yes, pay close attention to how to create components. And I've explained what components are a bunch of times. You can go back and look at those explanations again. So I'm going to click projects, and all of our components are for now going to live inside our SRC folder. You ideally want to organize this if you have a lot of components, but for now we just have maybe 2 or 3. So I'll just put it inside source. So I'm clicking on source and I'll create a new file. I'll create a new JSX file. So let me see if I have JSX. So I actually don't, so I'll just create a new file right here and I'll name it header.jsx. So I want a header component. I want something to be displayed above this study deck. I want to make a header component, and then ideally I want to put it inside my main like this. So like how I have my app component, I'll just have my header component in here like this, and then hopefully that'll load in and we hope for the best, right? So it's actually pretty simple. We created this header file and we've probably done 40% of the work already. So a component is a function, right? We know this. So we're going to create a function, header, and inside header, what are we going to do? Well, the first main reason that we create a component is to return something that looks like HTML, which is a JSX. So return something that looks like HTML, right? So we're going to return something that looks like HTML. And this is actually what I want at my header. So for example, I want something like, I want a header tag. Obviously, I want to be semantic. And I want a h1 tag. And inside it, I want to say study deck. And in the next line, I want to say, this is my header section. Doesn't look very pretty, but just trying to prove the point. Okay, so we made a new file. We created a function, and inside the function, we're returning, for all intents and purposes, HTML. Now, this HTML that we returned is going to have to somehow make its way all the way over here and to our screen. Okay, so the correct flow was main.jsx is going to render it onto our screen, right? So how are we doing it with app? Inside app, we're exporting it inside the app. We're importing it in our main JSX, and we're simply just rendering it in our root. So let's do the same for header. Let's see if it works. We're going to export default header, right? In our main.jsx, we're going to import header from ./header.jsx. Pretty simple. We just exported it here. We imported it here. And right here above our app, ideally, we want our header to be at the top. We're simply just going to, let's see, header and self-close this tag. And we're going to save this, and we're going to hope that it's going to appear right here, saying this is my header section right above this. And there we go. It does. Of course it works. What did you think? React is not that complicated. You make components, you export these components, you import these components somewhere else, and ultimately you render them. Okay, but one interesting thing is I had to render my header and I had to render my app in here. What if my app component itself makes use of multiple other components? And that is actually how it works. So the app is the entire component. The app will have a header inside it, a section inside it, a footer inside it. That section might have multiple components inside it. So let's just look at an example. Let's look at Facebook. And let's try to differentiate right here. So this whole page, I'll just ignore this for now. Just understand we have this whole page, and this whole page represents, yes, our index.htmls, this div root. So everything that's on here is being rendered from in here. Now, let's say this whole page is an app component. Inside that app component, I have a logo component maybe that renders these logos and create new account button. Maybe I have a register component that has these register for email phones and passwords. Maybe I have another component that says if you're making a YouTube video, then you're temporarily blocked from Facebook. Okay? So all of these are components, and sometimes components live inside other components. So if I wanted to put this header itself, inside the app. So I didn't want to load it differently right here. I just wanted to load app, and I wanted header to be inside the app itself. So first of all, I would remove this. I will remove this. I'll remove this, and we're exporting header, so that's fine. But instead of importing it in our main, I'll import it in our app, right? So we're going to import header from /header.jsx. And we're doing the same thing. Instead of importing it right here and cluttering our main.jsx file, I'll just import it to our app. And in our app, right before we do our study deck thing, I want to header and with a capital H, so you can use it like a component itself. So header, I used it like a tag. So I used it like an element. So this is basically an element that gets returned, and we're putting it on top right here. And we're taking this whole thing, exporting it, and rendering that whole thing with the header in our main using app. So we did everything just in one step so that our main has to only look at one thing, and our app can manage the headers and everything. So if you refresh this, you'll notice that everything will be the same. Now at this point, I want to look at the document object model, or let's just say I want to inspect the page. Let's inspect the page and see how it looks like. So we have our div ID root. So where does this come from? This comes from right here. This is what we're seeing right here. Inside our div ID root, if we open this, we have another div. I wonder what that is. That div is probably the div that has been given from our app, since we're putting this div directly using our main.js inside our index.html, right? So if you open up this div, yes, that div was indeed app.jsx. Inside app.jsx, you have your h1 and p tag. So you can see you have your h1 and p tag, but you also have this header element. This header element is coming from right here. And that element itself also has header and h1 and p tags, right? So if I open this, it itself also has header, h1, and p tags. So this is one element. This is one element put into our other element right here. You can look on the left for a visual representation. So this is our one element, header element, or header component, put into our app component. And our app component is rendered onto our page. So this is the entire page. Inside the page, we have app component. Inside app component, we have header component. So that is how the hierarchy is working right now. And I'm sure after all of this tedious explanation and you fast forwarding through this section many times, you've finally understood the basics of how to create a new component and how you can embed components within each other and render them onto your page. One last thing before I leave you in this section, you might be noticing, so this page right here, every time that I save my files, this page is just being updated on its own. Well, that is specifically because we're running it in dev. So you can see Vite, we're running Vite, and in our package.json, you can see that it is a dev script. So normally what dev script means is as you're editing, it will update on its own once you save the file or once you refresh this page. You don't have to manually restart the entire application for it to refresh. It just makes developing a little bit easier. And sometimes if the page isn't loading automatically or refreshing automatically when you're changing your files, it's probably because you're not using Vite or you're not using a development script from package.json. Okay, so it's not magic, it's just technology, I guess. All right, I want to clarify on JSX a little bit. Looking back at our component, we're doing this in multiple places. So we're adding elements like this inside our component itself. So we're creating a function, and let's just say component name, just name anything. And inside this function, we're returning. So we're going to do return, and then we're returning this thing, right? And this looks like HTML, and I've mentioned it a few times, but this is actually what JSX is. So it is basically a friendly way to write what should be on the screen. Remember, this entire file is inside JS. It's inside JavaScript. It's not inside an HTML file. Even though it's inside JavaScript itself, we can use HTML elements like this. That is because JSX and specifically saying Vite, our packager, is going to take our HTML looking code and then turn it into actual HTML and render it onto our page. That's all that it does. You just want to build something that looks like HTML. So looks like HTML, but is JS. Why is this really necessary? Well, that's because you can use JavaScript. It allows you to use JavaScript inside HTML. Generally, you'll have to attach scripts to your HTML to have JavaScript, but if you're using JSX, then simply when you return something, and let's say I have an element h1 and say my name is, and what I can do is using JSX, I can directly put in that name variable in here, and this will basically execute in a JavaScript context. And all of this is JSX, which then goes through Vite, and which then gets rendered onto your page. Okay, so we've been on React for a while. Now, I explained the problem statement of this chapter, and it's basically just explaining JSX so that you understand JSX better because it's the building block of React. We've already employed JSX right here, and we employ JSX right here, and inside main as well, we're using JSX. These are all HTML elements, so you can see these are all HTML elements that we're using inside JavaScript. And we return them. Vite takes that and then bundles it into our HTML so that we can see it on the browser. Okay, we get that much. But in JSX, there are 4 main rules. So I'd like to write it over here. There are 4 main rules that handle all of JSX. So let's go over our first rule. I'll actually maximize this so that you can see it better. So our rule number 1 inside JSX is that a component must return a single wrapping element. A component must always return a single wrapping element. Now let's see what that means. Let me put this back here, and in our file, we can see that there's a single element or single tag, well, element that's wrapping the entire thing. You can see we have header and close header, only one element. That element inside has these 2 other elements, which are the header tag and paragraph. Even inside our app, you can see we have div and we have div. So it's one wrapping element, and inside it we have 3 other elements. Even in our main JSX, you can see that we have strict mode, which is one element, and we have app inside it, which is also a single element, or in this case, a single component. What would happen, okay, so in this page, what would happen if I remove this div? So for example, if I remove this div right here and this div right here, I no longer have a single element that is wrapping all 3 of these. You'll get tons of errors immediately from your IDLE or your IDE because it does not like this. Your everything that you have right here must be wrapped inside one single thing. It could be anything. Right here we're using header, and here we were using div. So if I save this now and refresh the page, the refresh is going to fail. It's going to say transform failed, adjacent JSX elements must be wrapped in an enclosing tag. Did you want a JSX fragment? So it does ask if you wanted a JSX fragment. So if we put this back in our div, okay, so I'm going to put this back in my div, and if I save this, now my page is back. Let's inspect this page. So we've done this before, but now what I want you to look at is inside the div, you get another div. So this is our app, right? This is our app, which is wrapped around in a div. And inside it, we have our header, which is wrapped around in a header. But what if I wanted header, but I didn't want these header tags? I actually just inside here, as soon as I open this div, I want header to just sit outside. I just want it to sit right here at the same level with my app. Well, to do that, you simply cannot just remove header, right? Because if you remove header, if you remove this, and if you remove this, then you're going to get the same error again, and it's going to say transform failed. So you can't have it like this. But what you can do is use a JSX fragment. So using a JSX fragment basically means instead of writing header, you just put it empty. You just wrap it around in an empty element, and still it will work perfectly fine. It will load in. But now if I look inside my tree, as soon as I open up my div, and this is my app, you can see that study deck, this is my header section, is no longer sitting inside header. It is sitting outside. So if you want your elements to not be wrapped around in anything, so maybe I don't want this div outside here. As soon as I open up my root, I want everything in there. That div is this div, right? So I can just remove that div. And if I refresh, now everything is directly inside my root. All these elements, so all of these elements are directly being put inside my root div, right? But it's always a good idea to wrap it in div and in headers or like the sections that you have, because they're easy to style and organize. And honestly, it looks much better because if I inspect this, and if you look at it, you can clearly see that we have a div inside here. You can clearly see that we have a header section and everything else. So it's good to keep things organized like this. Okay, that was rule 1, a pretty long rule. Then we have rule 2. So you remember how we use class to assign something a class. For example, if I wanted to assign this header element a class, and see in normal HTML, I would do class equals to, and then I would give it a class like header icon or something. And then I could edit the CSS for this element by referencing this class inside CSS. Well, this class keyword doesn't really work inside JSX. Again, remember, JSX is JavaScript that makes use of HTML-like syntax. So this won't work inside JSX because class, as you know, in JavaScript, is a reserved keyword. So class already has a meaning inside JavaScript. That's why you can't use class. What you have to use is class name. And during compile time, so while compiling this, Vite automatically converts this into class and then renders it onto the page. So if I go onto my page, if I refresh it and then look at it, you will see that inside header, the header has the class header icon. Even though we're using class name here, it gets converted into class when it gets loaded on your page. So our rule 2 was class name, not class. Because we're in JavaScript, the word class is reserved. Reserved means it already has a meaning inside JavaScript, so we cannot use it. All right, let's go to rule 3. Rule 3 is that you have to close every single tag. So what does that mean? Some tags in HTML, you really don't have closing for them. Like paragraph tag, you have an opening tag, closing tag. But if you have something like an image tag, right? So when you have an image tag, you do img, and let's ignore this for now. And you don't really close that tag, right? You just start it and then you just let it be. But look what happened as soon as I didn't close that tag. I get errors all over my page. And if I restart this, it's going to say expected corresponding JSX closing tag for image. So it's always expecting a closing tag. So at the end, I do have to close that out with image like that. If I want to use any tag that doesn't close by itself, I have to manually close it like this. Now, fortunately, JSX has a shorthand syntax for this. You just put a slash in here. And all this does is it opens the tag and closes it itself. Even inside your app.jsx, you can see that the header is a simple one-line tag that we're importing. So we're exporting this component right here. And we're importing that component inside this section. And we're using it, but even though it is one component, we have to start and we have to close it out. We close it out by simply just doing a backslash. Even in main.jsx, you can see that strict mode is opening and closing, and app is also self-opening and closing in the same tag. So rule number 3 is simply just close every tag. Use shortcut of slash. Just use slash as a shortcut. And the final rule, rule 4, is that JavaScript goes in curly braces. So we will explain this in the next section as well. We have a whole unit for this. But basically what this means is if I wanted JavaScript anywhere inside this HTML, right? Anywhere inside this, I can insert JavaScript. And that is simply by doing a curly brace. And I can do something like 2 + 2. And if I save this and refresh this, you can see that we get a 4 right here. Let me put it in a spot that's more visible. Let me put it in the h1 tag. So study deck and then output 2 times 4, right? You can see that JavaScript, technically 2 times 4, if you did this like this in HTML, it would just print out 2 times 4 itself. But in JSX, since we're using JSX, the advantage is that we can directly insert JavaScript wherever we want simply by using curly braces. So by using curly braces, you can put in JavaScript. Now, obviously, you will rarely just have numerical operators like this. You'll probably have functions or something of that sort. But just understand for now that inside normal HTML, CSS, JavaScript, you couldn't do this. You had to put a different thing here. You have to make a script tag. Oh, it won't even let me make a script tag. So you had to make a script tag separately like this. And then you would probably have to write JavaScript here like a equals to 2, b equals to 4, and c equals to a times b. And then you'd probably have to get this element. So you'd probably have to say something like const header equals to document dot get element, blah, blah, blah. You'd have to get the element, and then you have to do header dot inner text equals to, and then you'd have to put study deck. So something like study deck, and then plus, and then finally put C. So like you probably have to do something like this if you did it in plain HTML. You'd have to attach a script and then define all of these variables and do all of this stuff just to change it. But the power of JSX is you can directly just run JavaScript inside here like this. So we'll be looking at that fun ability of JSX to use JavaScript directly inside HTML in this section more. So I'm just looking at my app component, right? Now I'll just show you a brief demonstration of how we can use this. First of all, I want to remove the JavaScript that we added earlier so that it is now study deck only. And I can do something like this since this is plain JavaScript, right? So outside here, obviously, I can do stuff like const name equals to study deck. I can do this because this is just plain JavaScript, and JavaScript are allowed to have variables like this. But the fun part is instead of study deck inside my header tag like this, I can take it all out. So taking it all out, we'll just remove it for now. And I could pass in name like so. So any variables that this component has access to, those variables we can directly load into our HTML using curly braces. Simply use curly braces and put the variable name in, and any variables that you have can directly be loaded onto the page like so. In normal HTML, you would just get this exactly how it looks like. Okay, and then again, in the next tag, you can do something like 2 times 2, of course, very simple stuff, and it would show 4 instead of just showing 2 times 2. But this is where we really use it. So I'm going to create a paragraph tag, and you can do name. You can apply JavaScript methods. So name.toUppercase is a method that we have in JavaScript that simply just converts a string all into uppercase. So anything that this method returns will be put into the JavaScript right here and loaded onto our page. So we can see that we got study deck in capital letters right there. So you can do a bunch of functions like this. You can put whatever you want inside it. You can literally put a function inside of the JavaScript. You can directly insert a function. And this function can, do a bunch of stuff that this element will then execute. So you can do a bunch of interesting stuff with JSX. Now you try it. Put some stuff, create some variables, and create like a basic structure, put some variables inside tags, and see how you can play around, maybe try some functions that you already know from JavaScript, and we'll meet in the next unit. Components, right. So we created a header component, which is at the very top of our page. But in our page, we'll have lots of different things, right? And all of those different things are components, like the Facebook example I showed earlier. And they're just going to be used and reused over and over again in different places. You just have to make it once. So we're going to create a very core functionality of this project. And I'm going to create a new file. And this file is going to be named flashcard.jsx. So I'm going to get a component, or going to create a component for a flashcard. You remember how you study? When you study, the flashcard has a question, and then if you click on it, then you can see the answer. So you can practice your answers without looking at them by looking at just the questions. So again, this is a component, and a component is just a function in JavaScript. So I'm going to create a function, and I'm going to call it flashcard. Remember that your function name has to always match your file name and has to always have a capital, start with a capital. I'll delete these comments because I assume you know this by now. And inside it, I'm going to create a couple of variables. So like in app, we created variables before. Now we're going to create some variables inside flashcard. So I'm going to create a variable called question. This flashcard is going to have a question, and it's going to say, what is the capital of Japan, for example? And then I'm going to create a variable answer. And inside answer, I'm going to have the correct answer, which is Tokyo. Okay, I have my question and I have my answer. So that's pretty much all I need to create an HTML. So to return an HTML, so to return a piece of string from a component, you always use the word return, right? It's quite obvious, right? So use return, and then now you start writing your HTML. So you put your HTML right in here, and it's going to return it. So remember, you always need to have an outer wrapper. You can only return one element. So everything that we're going to return, I'm going to put it inside this div. You can only return one element. Inside header, we're returning only the header element. Inside app, we're returning only the div element. You cannot return multiple elements from one component. Okay, I'm going to have a div, and then I'm going to have a paragraph, and this is going to say, for example, geography. And then I'm going to have another paragraph that's going to have the question. So notice how I didn't have to type out the question. If I change the question at the top here, the question will change inside this paragraph automatically. And I can use this variable anywhere where I want the question. Then I'm going to get a paragraph for the answer. So I'm just going to write answer right here, and that's going to create a paragraph for the answer. And of course, at the very end, you have to export default flashcard, right? Because this is your component, and you have to export it so that any other component can import it and use it. So where are we going to use it? Are we going to use it in main JSX itself? Well, not really. Usually you don't touch your main JSX to update small components like this. You put it all inside app, and then app itself gets shipped as a component to main JSX, which renders on the page. So flashcard is first of all going inside app. So I have to import flashcard. So let's import flashcard. So we exported it here, and we're importing it here. And we're going to use flashcard. So we're going to use whatever flashcard gave us with somewhere in here. Let's say I want it right after header. So right after header, I'm going to put in flashcard. And remember that this has to be closing. So you have to close this tag. And that should be everything. You want to export app, and then you go to your main JSX, which puts the app into our index.html. What was in our flashcard? Well, we had a div, and inside the div, we had 3 paragraphs. The first paragraph said geography. Second paragraph just gave us the value of this question variable. And the third paragraph gave us whatever was inside the answer variable. Now, if you refresh the page, or if you click on the page, you can clearly see that it says geography. What is the capital of Japan? And Tokyo. So everything that we made from our component right here correctly got imported into app.jsx, and app.jsx exported itself, and it correctly got imported inside main.jsx, which then put into index.html. So I'm going to give you styling for this. Currently, we're just using the custom styling or the pre-made styling that came packaged with this application. And let's look at it main.jsx, and we're importing index.csx. So index.css is right here. We have app.css as well. We have index.css, and this is what's rendering all of our CSS on our page. So I'm going to remove all of this. As soon as I remove all of this, my page is going to look pretty normal. It looks like a basic normal HTML page. And that is how it's supposed to look, because all we've done is written plain HTML right here. We're just writing a div inside app.jsx. We're just putting header and flashcard. Our header is also just literally a div and h1 section, paragraph, and img. So flashcard, so styling. Currently it looks kind of boring, but I want to add our own custom styling. And since this is not a CSS video, I'll skip right through the styling. I'll just briefly show it on the screen so you can add it. So I copy pasted my styling right here. I'll rearrange this slightly so that it's much easier for you to read. So font family sans serif, max width 800 pixel. I have some margins, some padding settings, and I've done something similar for deck. So anything with .deck is going to be a flex wrap. So I won't really go into detail on CSS in this section or even in this video because we have much ground to cover. If you don't understand CSS for now, just copy along, just copy paste this code and we can move on. And that is all. So I'll save this and let's go back to our page. And you can see that nothing actually updated. That's because we haven't assigned those classes yet. And let's assign those classes real quick. So I won't dwell so much time on this as well. So our div itself is going to be of the class name. So remember, you have to give in class name, and it's going to be card. So the class name is card. Our geography title is going to have the class name of category. Our question itself is going to have the class name of, you can see that it automatically fills out the class names for you. So it finds those for you and then gives you suggestions. That's why I like using IDEs over IDLEs, because some of these powerful features aren't possible on IDLEs like VS Code. So question right here. And then for our answer, I'm going to have class name and answer. So all of those should be styled for now. And if I go back to the page, you can see that we got one card. So we got like a flashcard, and the flashcard is stylized using CSS. And we can see that it's a single tile, and we can use and reuse this over and over again. We just need to change the question and answer, and we can reuse this, maybe change the category as well, just like that. Now, maybe I wanted 3 cards, right? Not just one card. Well, let's go into our app.jsx, and right after our header, I'm going to create another div, and inside this div, I'm going to put our flashcards. So flashcard, I'm going to put 3 flashcards like so. And if I save this, you can see that we got 3 flashcards kind of in a horizontal position, and they're not really styled because I haven't given my div styling. So if I give it class name, and the styling that I gave called app. So inside index.css, I had a styling for app. And if you apply that, you can see that it moves a little bit to the center, and then you can see all of the cards against each other like so. So all we created was a real component in React again. We've already done this before, but we created another component. And then we looked at how to insert JavaScript into that component. So we inserted JavaScript into the HTML of that component. And inside app.jsx, we learned how to multiple use different components. So every time you want a flashcard anywhere on your website, you can simply just use this component and then create a flashcard. All right, for example, we have our page right here. And inside the page, we have a bunch of cards stacked like this currently. And each of these cards, I want each of these cards to have different questions, right? You want them to have different questions. So the way we do that in React is by using something called props. So props are basically like arguments in JavaScript. Component itself, so each of these little small things is a component. Our component starts as a blank template. It's just like a placeholder for things. Now it might have a placeholder for category. So it might have a placeholder for category, it might have a placeholder for question, and it might have a placeholder for answer. Like how we saw before, you can insert variables directly into JavaScript. So we can do this. So what we're going to do is we're going to use props. We're going to use props, and every time that we render this component, we're going to use props to give in different values for the category, for the answer, and for the question. And while doing that, we render them so that each of these cards that we see on the screen will have different values and different questions and answers inside them. Let's see how you actually pass props. Each one of these cards are just a component. So we created a component called flashcard, and each of these cards is just a component, and inside app.jsx, I am importing that component. So I'm importing flashcard, and I put 3 of them on the screen inside a div, and there's a header on top. Okay, so far so simple. But each of these cards has a pre-baked question, or like, if you can see this one, it says, what is the capital city of Japan? And that same question is repeated for every single card that we have. And if you want to change that question, we would change it right here. So what is the capital of US, for example? And if I save that, then it would change to what is the capital of US, but it did that for every single card yet again. Now, generally, you just want one card to have one thing, another card to have another thing, and another card to have another thing. So you do that by passing a prop. Props are similar to HTML attributes. So all you actually do is you need to come over to your app.jsx. So in your app.jsx, right after when you're calling flashcard, so when you have your flashcard element, you can just send a attribute, like an attribute. So you can send question, and I can say something like, what planet is the red planet? And this question automatically gets sent to my flashcard. So inside flashcard, I have to actually receive whatever I'm sending right here. Right here, I'm sending a prop with the name of question. And inside flashcard, currently my question is just this variable, this constant variable right here that we're printing out by using JavaScript. But instead of doing that, what you can do is you can do props.question. So this question will no longer be used. So we can cut this out of our text, and we can see that props.question. But you can see props says unresolved variable or type props, because this is actually never defined anywhere. So you just put that at the very top in the argument section of your flashcard. So now app, whenever your app sends a prop like this, whenever you're calling a component, when you place a component and then call a prop like this, it goes to the function. It is passed as an argument to the function, and that function inside can access those attributes that you sent by simply using dot notation, because everything is an object in JavaScript. Okay, now if you run it, then you should see that the first one will say, what is the planet? Red planet. So it said, what planet is a red planet? Now, for the others, I haven't sent a question yet, so props.question will be empty for them, right? Understand the logic here. Every time you write flashcard element, one of these instances, one of these will be put on your screen. You can customize the text inside it by sending something called a prop. The prop needs to be accepted by that function. Once it's accepted by that function, you can access stuff that you sent using props dot and whatever you sent. In the first case, we're making an element and then we're sending what planet is a red planet, and we see it right here. But in the second case, we're making that card, so we're making that component, but we're not actually sending any props. So when this card tries to do props.question, it finds nothing and just returns us with something empty. Simple as that. So I'll fill out these with questions. And now if I go into my page, I can see these questions. And like so, I want you to put the answers in as well. So instead of hard coding the answer with just answer and having a constant Tokyo, I want you to write an answer for each one of these questions. And I want you to do that yourself. And we've achieved this, but the downside of this is that you see props. So every time you want to send another prop, you would do something like answer equals to ABCD. And inside flashcard, instead of answer, you do props.answer. But what if you needed to send more than just like 2, 3, 4, 5 fields? What if you wanted to send, let's say, 10 or 20 fields that you needed to send? Well, it would be quite inefficient to do that by just passing in props like this for every single one. So doing this for every single one would be quite tedious. That is why we use destructuring, and we'll be looking at what destructuring is to receive props cleanly. Okay, for this part to make sense, you have to understand that everything in JavaScript is an object. So everything, like if you even create props, for example, props itself, right? Props itself is an object. Props equals to something like this. And inside props, you might have your question. So you might have question that sits like this, and then you might have a question. Then you have an answer, and then it sits like this. So this is what's actually being passed onto our flashcard. So in this instance, when we're passing in the question and we're passing in the answer, we're passing actually a prop. So we're passing a props object. And inside that object, there is the question and there's the answer. And right here, we take that object. So we take that object. And since in objects, you can access the key values inside the objects using dot notation, we're using a dot notation to access it by using props.question and props.answer. But there's a much cleaner way to do this, and that is through destructuring. And it's pretty simple actually. So instead of having props.question and props.answer in here, we can directly see we're getting question and answer, right? So in here, instead of taking props, I simply destructure that object and then get question and get answer. So simply right here, I'll get the value of question and the value of answer from that object. So whatever question and answer that we passed into that object, we get it. And right here now, instead of props or question, you can simply just do question. Instead of props or answer, you can simply do answer. And if you save this, it says answer cannot be redeclared because we already have an answer variable here. Just delete this one. And if you save this now, you can see that it works perfectly fine, exactly how it did before. Now let's give every set of card its own full data. So let's set up our own flashcards. So I'll delete all of this and let's set it up from scratch. I'll maximize this for now. Well, let's look at it after I finish writing all of this. Okay, so the first flashcard I want, let's actually, instead of saying app, let's say deck. This is my deck and I want a flashcard. And in this flashcard, I want a category. So category may be something like geography. And I want a question. Let's say the question that I want is, by the way, you can't have spaces here. What is the capital of Japan? And then I'll have an answer. So answer will be Tokyo for that. And remember, this tag has to close. So to close it, you must always put a slash and then close it like so. Next, I'll just copy this flashcard down like 3 times and I'll make one of science. So science, tap that. Instead of geography, I might have math. And let's change the question. So what is the capital of Japan? Let's say, what planet is the red planet? And of course, the answer to that is Mars. Then for mathematics, I can do something pretty simple. What is 7 times 8? And the answer will just be 56. So all of these are strings, by the way. You cannot have numbers in here. Okay, so I created 3 different flashcards. And all of these 3 have their own categories, question and answer. So when we're creating this flashcard, we create a props object. So a props object is created like this. A props object is created. And inside this object, there'll be a few things. So there'll be a category, and then whatever the category we pass will be put in here. So for our first case, let's just go with this. So it'll be geography, something like this. And then you'll have a question. And then the question will be, what is the capital of Japan, like this. And then you'll have the answer and it'll look like Tokyo. So when we're creating this flashcard, or when you're putting this flashcard onto the screen, a props object like this is created and it's sent to that flashcard function. So inside flashcard function, we get this object. So let me cut this. And inside flashcard function, we're actually getting this object. So once we get this object, I can do one of 2 things. So I can directly put props here, and anywhere I want category, I can do props.category. Anywhere that I want question, I can do props.question. And anyone I want the answer, I can do props.answer. So for the first card that we make, the category is going to be geography, this, and so forth. So instead of doing this, what we can do is directly destructure what we learned before. And in destructuring, I'm simply just going to pull out category, the question, and the answer in that order. So whatever order that you give it in, that order is taken out. So I got category, question, and answer. And now I no longer have to use props. I can simply just do category, question, and answer like so. Okay, so for category, I'm simply just going to pass in the category, question, and answer. Simple as that. And let's look at our page. Let's refresh this, and we can see it right here. So it says, what is the capital of Japan? We say Tokyo. And next we have science. What is the red planet? We have Mars. And next we have maths. What is 7 times 8? And the answer is 56. Just like so, I want you to add your own category, question, and answer, and then just fill it up a little bit. Add a few questions, add a few answers and categories, and I'll see you in the next section. But what if in any card I forget to pass in an argument? For example, for maths, I forgot to pass in the maths one, so the maths category. If I save this, I can see that maths just disappears because nothing is found, so it's not drawn on the screen. Well, that doesn't really look nice. We can do something called default categories. So inside here, we can set category equals to general. And what this does is, by default, this category is always general. So the value of category by default is always going to be general. Unless from your app.jsx, you're sending a category explicitly. So for the first one, we're sending a category geography. So this general gets overridden, and then we get category geography for the first card. In the second card, we're sending category science. So this category general gets overridden, and in here we get science. In the third one, we're not sending any category. So hence this doesn't get overwritten, and in category we're going to get general. So if you forget to add your categories or you forget to add props to any field, make sure that you have defaults. So like in category, I have a default general. So this currently was from the previous run where I set no category, but now I'm setting it to general, so this should appear as general. And if I click on it, yes, we do get general. That's because I didn't pass in a category explicitly. Now, if I were to go ahead and pass in a category again, and then say it was mathematics, so if I said something like that, and if I came back here, this is going to change to mathematics. If I remove the category geography, then we would get general right here. So general is like the default placeholder for the categories. Okay, so last section we talked about props. And props is basically the element, let's say element, I'm putting it in quotation marks, that is sending attributes, again I'm putting in quotation marks, attributes to our component. So once our component gets these attributes, then we can show it by simply using props dot something, or simply by destructuring it and then showing that something directly. So the whole structure was that, and if you're still unsure about this, you should go to your previous section and learn about it properly. But currently, our card, so we have our card right here, and our card directly shows our question and our answer. Well, we don't really want that, do we? What we do want is we want a card, and in the front we have a question. And when it's flipped, when we flip it, then we get the answer. But there's a problem here. So this is what we're trying to make. This is what we're trying to make, but there is a problem. Since this question itself and this answer itself are being passed as props, they're being passed as props. One important thing about props is the component cannot change props. That's the important thing. The component itself can never change the props that's given to it, right? So how do we check? Well, we have to do this one word. We have to remember. What do we have to remember? Well, we can do something like, is this card flipped? Is the card flipped? Well, if yes, then show the answer. If no, then show the question. So we can do this by using something called state. So this is what this whole section is going to be about. We're going to learn about state. So once again, To reiterate my problem, currently we have our card, and our card shows the question and answer at the same time. We want the card to show the question, and when we click on it, we want it to show the answer. To do that, we have to remember if the card has been flipped or not. If it's flipped, we show the answer. If it's default, then we have to show question. Now, to remember if it's flipped or not, we use something called state, and that's what we'll look at in this section. State, right here, inside app.jsx, we're sending all of these props, right? We're accepting these props inside our flashcard and we're showing them on the screen. Now, this flashcard function, inside this function, we cannot change the values of these props. So we cannot change these props inside the function. That's why we can't know if they're when to show a question and when to show an answer, because we cannot change these values. They stay fixed. So to write it right here, props come from the outside. Since flashcard is getting it from the outside, we cannot change what outside sends us, right? It sends us what it sends us, and they stay fixed. What we can do is we can do state. So state is something, just know that state is something for now. State is something that lives inside the component itself and can change, okay? So props come from the outside. We cannot change the category, we cannot change the question or the answer, but state is something that lives inside this component itself, and state can change. But an important and good thing about state is that every time a state changes, React redraws the component. So when do we draw the component right now? We draw the component whenever it's called. So the first time that we make it, we draw the component. But after we draw the component once, we never check if the component has changed to redraw it. Well, the page reloads on its own because inside debug, you can see that I'm actually using Vite somewhere over here. You can see that I'm using the dev script, which is running via Vite. That's what the page reloads for me, right? But in a production server, you're not going to manually refresh your page every single time you click on a card. It has to do that automatically. So state every time anything changes inside the card. So if I change the name or if I change the answer, whenever I change that, the state is going to refresh the card and then create it from scratch. Terms at you right now, and I hope that you remember most of them. If you're finding it difficult, then you might want to write something down. So far we've covered components, we've covered props, and we've covered what state means. So you have the idea of what state is, but you don't exactly know what it is yet because we haven't used it. So the way you use a state is at the very top, you have to import it. So you have to import useState from React. You have to import this module or import this component from React itself. Then you can add this state, so you can use this state inside the component by doing something like, and we've seen this before. So we saw this at the very first counter app. We did const is flipped and set is flipped. And we're going to use state and we're going to set this to 0. Okay, actually, it's not 0. We can set this to false. We can set this to be a Boolean. Okay, what exactly are we doing here? This might be a little bit complicated, so please bear along. Use state false. So this is the first thing. Use state false, the right thing that we have right here. What it does is it creates a memory slot that starts as false. In our case, the false is flipped. Is the card flipped? It starts as false. So use state false basically is creating a memory slot. A memory slot is being created, and that memory slot has the value false right now. What are we using that memory slot for? We're using it to check if our card is flipped or not. By default, it starts with false. Okay, next. It hands back two things. You can see here, we're using those two things right here. The first thing is flipped. We get is flipped. This is the current value of that memory slot. So use state creates a memory slot. The initial value for that memory slot is false, and it returns two things if you use it like this. The first thing is a variable or a reference that stores the current value. Currently it's false. The second thing is set is flipped. And this is the only way to change it. So useState gives two things. First is the current state that we're at, which gets stored inside isFlipped. The second thing is a way to change that state. And this is actually the only way to change that state. And what you need to understand is every time that we change the state, the component redraws. So the component gets redrawn onto the screen. If we use setIsFlipped to set the value of this memory slot to true, then this component will refresh. This component will be redrawn on the screen. If we use setIsFlipped to set this memory slot's value to false back again, then this is going to be redrawn again. You need to read this line as a pair, and you'll be seeing this line multiple times in your React applications. So this is the function of state. State gives you memory. The first is the value. Always remember, the first is the value, and the second is like the button to change it. You always get them in that order, value first, and what we call this is the setter. The setter is second. Setter is always the keyword set plus that value's name, okay? We have memory inside this component now. But memory is useless if you don't put things inside it and if you don't use it properly. So this officially gives our component memory, and now we'll be using this memory to change our card. Okay, when do we actually want to change this card? That is the first question that you need to ask yourself. We want to change it whenever the user clicks on the card itself. Whenever the user clicks on the card, we want to flip it. All we want to do is use setIsFlipped to reverse the current isFlipped status. So if it's false, then set it to true. If it's true, set it to false. And we'll look at how to do that. But two things need to happen. First thing is that we need to click on the card. Second thing is we need to use setIsFlipped to reverse whatever state it is at currently. So card, we have our card right here, and we can attach a property, attach a method, and that method is onClick. OnClick is an event. So event is anything that you do with your mouse or keyboard. Anything the user does is an event. In React, we can add one by using onClick like this. Simply inside a div in your JSX, you can add an event like this. So on click, I want to do something. Inside on click, I want to execute an anonymous function right away. And this function is going to set isFlipped to not isFlipped. Okay, let's dwell on this line for a little bit. First of all, we have an event. The event is on click. When does this trigger? When we click on this div. When we click on this div, so this entire thing, whenever we click on anywhere inside this card, the onClick event is going to be triggered. We can put this onClick event inside category. So like then every time you press the category itself, then only the card would flip, but that doesn't make sense. Okay, the first property is an event, which is onClick. After that, we have curly braces, and inside curly braces, something is supposed to happen. So on click, we can do something like console, for now, console.log, and we can say card was clicked. If you do something like this, then whenever we click that card, this is going to be printed out. This is going to be console logged out. So if you open up our console right here, and I full screen this and go to my console, and if I click on this, then you can see that I get, if I refresh this, whatever we want to do to this card, once we're clicking it, has to be inside these two curly braces. So anything that we want to do should be inside this. On click, what we want to do is we want to set isFlipped to not isFlipped. So the way you do that is you always need a function that is going to execute when you click. Now there's different ways to create a function, right? You can do function, this component itself is a function. So you can do function and you can name it reverse flip and then create a function and then is flipped if is flipped. Okay, this function isn't inside the context, so you can put it inside the context right here. So you can do function if is flipped equals to true, then set is flipped to false, then set is flipped and then set it to false, else then set is flipped to true. Now look at what happens if I try to change is flipped manually. So instead of doing set is flipped to false, if I try to do is flipped equals to false directly. So I'm directly trying to assign a false value to is flipped. Well, this isn't possible because is flipped is just a way to show you what's in that memory slot. It's not a way to change it. The only way to change it is by using the set is flipped method. So this would be non-viable. What you have to absolutely do is set is flipped and then set it to false by yourself like this. So reverse flip. If flipped is true, then set it to false, else set it to true, right? So on click, whenever you click that card, then you simply just want to call the reverse flip function. This function will be called, and then if is flipped is true, then I'll set it false. If it's false, I'll set it to true. But this is a very lengthy way of doing it. This is just so that you can understand what's going on behind the scenes, but we use shorter hand syntax for this. So instead of reversing flip, calling a function right here, we define a function in here only. So like function reverse flip, and then we write the function inside here. And instead of that if statement, what we can do is we can simply do set is flipped to not is flipped. So if is flipped is true, then set is flipped is going to set it to false. If it is false, then it is going to set it to true. Simply just going to reverse that whatever the value of is flipped is. And this can further get shorter because you don't actually need a name, right? Because you're calling it right inside here. And might as well remove this function keyword as well. Removing that function keyword, you get an error right here, and this is where our fat arrow goes in. So simply put in an arrow like that, and you can bring this all back down to one line, and now it looks like so. So this was the total syntax of everything. And you no longer need this curly braces as well because there's just one line of code. So we basically took that big function that reversed whatever flipped was to make it into this small function. Basically, whenever we click, we're going to execute whatever's inside these curly braces. And inside there is a function. So we have an immediately invoking anonymous function right here that is simply just going to reverse the direction of that flip. Okay, I've dwelled on this enough. But if you look at our page right now, whenever I click this, in the memory of my application, the value of this set flipped is actually being set to true, false every time I click it. It's just that we're not doing anything with that value. That's why we don't see anything on the screen. Now let's actually show when the answer when we flip it. Right now, what we can see is that we have the question and answer both on the same card. Okay, what we want to do is we want to check if the card is flipped, and if the card is flipped, we want to show the answer. Otherwise, we don't want to show that answer. So to do that, we simply just use something called a ternary operator. Ternary operator is just a basic one-line if statement. So is flip question mark. So we're checking if is flipped, and the first is the true condition, second is the false condition. So I'll write it down right here, ternary operator. So you start with your variable. You start with your variable right here. And then you do a question mark. Then you put what happens if that is true. So instead of variable, let's say condition. If that condition is true, then you put the statement there. If it's false, you put this statement right here. So is flipped is our condition. If it is flipped, we want to show the answer, right? If it is not flipped, then we want to show something like tap to reveal. That should be enough. And now if we go to our page, we can see that all of these cards have tap to reveal, tap to reveal, tap to reveal. And when you tap on them once, then you see Tokyo. If you tap on them again, they go back to tap to reveal. What's actually happening is whenever you click, then set is flipped is reversing the value of this. So it's going to set false to true or true to false. When it is false, you see tap to reveal. When it is true, you see answer. So by default, all of them are false because the initial state is false. If I set initial state to true, then all of this is going to go to true, and then you can see all of them. And when you click on them, they give tap to reveal. Okay, so initially, I want my cards all to be hidden. And when I click on them, I should be able to see the answers like so. Now, there's lots of different ways to show the card itself. Right now, I'm just making this bottom answer hide. What you can also do is you can entirely avoid this line, and in the class name, so the question right here, inside your class paragraph, what you can do is you can check is flipped, and if it is flipped, then I want to show the answer. If it isn't flipped, then I want to show the question. So you can do something like that too. So yeah, oh, I did the opposite. So question right here and answer right here. Okay, so by default, it is going to show all the questions. And if you click on them, it's going to show the answer. If you click on them, it's going to show the answer. If you click on them, it's going to show the answer. And this is basically like a very mini project that we finished. We didn't touch app at all. If you noticed, we haven't done anything inside app. We left it as is whenever we passed props. What you have to remember now is each flashcard has its own little memory. Like clicking on this flashcard doesn't make the others flip, does it? Even though all of them have their own is flipped. That's because they're isolated. Clicking one doesn't affect the other. They're perfectly independent of each other. So in this section, by the end of the chapter, you should have learned about state, you should have learned about events, which is the heart of every interactive React app. We have a few cards that we hand typed in our app, but what if we have like 50 cards or 60 cards that we need to add? Typing 50 flashcards like this would be madness, honestly. So next chapter, we're going to keep our cards as data, and we're going to make React build them for us automatically. Okay, again, to recap, what do we have currently? We have our screen, and now we have a bunch of cards. We can flip these cards to see their answer and their question. But what are we doing right now? We're doing a lot of manual work. Manual work as in we're creating the cards ourselves inside app. Now in this section, what we're going to do is we're going to create a list. So we'll have a list like this with card 1, card 2, card 3, like this. And this will be a list. Now what we're going to do is we're going to take this list and then we're going to give it to React. And React will make that list appear onto our screen automatically. So React will do a bunch of stuff to make those lists appear onto our screen as cards. So we're going to provide cards inside this list, and React is going to make them available. Now, what's the advantage of doing this? Well, the advantage of doing this is, for example, I want to show card 1, but I want to show card 3 as well. But in certain situations, I don't want to show card 2. Or when I don't have any cards, I want React to show something else. Or when I have a specific number of cards, I want React to do something. Well, that way, if you put it in a list, then we can count things like how many cards we have and stuff like that, so that it's easier to work with in React. So the method that we're going to be looking at to do this is called .map. And if you're familiar with JavaScript, you'll know what .map does. You probably already know .map a little bit. So we'll be exploring what .map does in this section. Also, there's a small thing about keys in React, and we'll also explore what keys in React do and why we need them. This section is we're going to tackle how to make this neater. Right now we have a flashcard, so we write flashcard and all of these props every time we want to create a new card. And that's not efficient because I can't keep track of how many cards I have. I cannot uniquely identify a specific card, and it's a whole mess, right? The most efficient way to handle this is by using something called lists. So we're going to put cards as data and not hand type tags. So these are hand type tags. We're going to store them as data. So we're going to store cards as data, or more accurately, arrays, which is just a list of items. And these items are actually going to be objects. So items or objects. Okay. So we can get something called, we can create a constant, and then we can call this list initial cards, for example. And I'm going to create an empty list, right? Inside this list, I want all of my cards, and I want to do something here that will look at my list and then show all of my cards on the screen. So inside here, I want to put my cards. Now, how do I want to put my cards? Generally, you'll use objects to organize your cards. So I'll use an object, and to create an object, simply put curly braces. So I'll give this thing again. So I'll give category, question, and answer. Similar to this, category, question, and answer. Instead, I'll have commas right here. And instead of equals to, I'll be using colons. So colon, colon, and colon. Category, question, answer. And I'll duplicate this for science, and then I have mathematics. So I'll copy mathematics. I'll copy the question that I have, and I'll copy the answer as well. Okay, so let's do one more. Also, you need to separate these objects itself by commas. So let's do one more, and let's say this one doesn't have a category. You know, just for uniformity, let's say this one doesn't have a category, so it gets what? You should remember this, it gets general by default because our default category is general right here. Revise up. The question, let's say, what is the capital of Japan? And the answer is going to be Tokyo in this case. Okay, what we did here is we created our deck. Let's call it a deck, our deck, which is a bunch of objects. Each object is one card's data. So anything separated by curly braces or anything inside curly braces in JavaScript is an object. So this is an object. The first key value pair is category and science. Second key value pair is question and what planet is the red planet. Third key value pair is answer Mars. So like so, we have three objects right here, okay? And we have three elements right here. So instead of writing elements, we wrote objects. But it looks like we did the same amount of work, no? Pretty soon it's gonna look like we're doing more amount of work to do the same thing. But keeping objects makes sure that you can look at, you know, the length of this list. You can remove and add objects easier to this list. And anything that you add here, you can automatically render anywhere on your page by simply looking inside this list. It's just keeping things organized. Sometimes programming is not just about shortest code or the least amount of code. It is also about the way you define your code. So it must be easy to read, easy to modify, just more efficient to handle. And instead of hard coding our elements like this, it's much easier to handle if we have a list of objects like this. So right now, all of our cards are being rendered onto the page. So I'll copy this, I'll open up my Chrome, and then I'll open this page. Okay, so our cards are being rendered like so. And the cards that are being rendered are these cards right here. So you'll notice if I remove one like this, that card is going to get removed. And if I add it back, then it's going to come back. So we're kind of hard coding the cards right now. What we want to do right here is, instead of hard coding our cards like this, we want to create like a loop, something that loops through all of my cards that I've created here, and then creates the actual elements for me. Also, it seems like by default I'm getting the answers, so it's probably because of this. Let's flip this. If it is true, then answer, else it is supposed to be question. So then I get the questions. Okay, so simply, first of all, I'm going to remove all of my cards. So I'm going to take all of my cards, I'm going to remove it. I'm going to remove this fragment as well. And now I have an empty div. If I go to my page, I have an empty div. Now I want to load in these three objects as cards inside my element. Now I'll full screen for this, and this is something that you'll use a lot throughout your React journey. So please pay attention. Well, the first thing is that the map function is JavaScript. So to insert JavaScript inside HTML using JSX, we always have to use curly braces, right? Even here, we're inserting a variable directly into HTML or directly into an element. That's why we're using curly braces, so that these curly braces signify anything that's inside here is JavaScript. So we need to also specify that whatever we're going to put inside the app is JavaScript. That's why we need to start with curly braces first and foremost. Then we're going to go through every card in the list and build a flashcard from it, okay? And the way you do that is you take your list is initial cards, so initial cards, and then you put a dot map function on it. Now, dot map is a higher order function. We've looked at an example of a higher order function, which is onClick. It basically takes a function as an argument. It puts a function inside it, and whatever this function returns, it works on that, okay? So inside map, we need another function. Now, I'm sure you're familiar with this syntax by now. It's just a shorthand way of writing a function in JavaScript. So we're going to use that syntax. We're going to use that syntax right here, and we have a function. So initial cards.map is our outer function, and inside it we have another function. Okay, and all the logic goes inside the inner function. Just follow along for now. You'll do this a bunch of times and you'll get used to it. So what's happening is .map is going to one by one give me all of these cards. So the first time .map runs, it gives me this card. The second time .map runs, it gives me this. Third time, it gives me this. So it gives me the cards one by one. Well, how does it give it to me? Well, it has to give me a card somehow, right? So inside here, I'll just write card. So this is how it passes it on to me. This function passes that card as an argument to the inner function so that the inner function can now do something with that card. In the first iteration, this card is going to represent the first index, then the second index, then the third index. Okay, that's pretty clear, I think. Now what we want to do is we want to create a flashcard for every one of those. So let's do that. Let's create a flashcard, and inside the flashcard, we need to add a bunch of things. Let's close it right here. Inside the flashcard, we need to give some props, right? Where are the props? Well, the props are provided to us by category, question, and answer. That is inside the card that we got from map. Okay, so we start category equals to, and we can do card dot category. Next we have question, so question equals to card dot question. Next we have answer equals to card dot answer, and it should be as simple as that. Now you must be getting an error here. Okay, so these should be not curly braces, but instead small brackets. So simply remove that and put in small brackets right there. And let me delete all of this extra space so that you can see this properly. Okay, so we're going to, actually this should be in the same indentation level. So I'll put it in the same indentation level. Okay, so we're going to go through every card. Let's see this one by one. For each card in the list, .map is for each card in the list, make it a flashcard. For each card in the list, make it a flashcard and pass it that card's data. So for the first time, it's going to make a flashcard out of this, and it's going to pass in this category, this question, and this answer through card.category, card.question, and card.answer, because we put that card right here. For the second time, this entire object is going to come and then live over here as card, and card.category would give us this object's category. So we go through that one by one to build 3 cards. Now let's look at our page and see if that loads up. So if you refresh our page, or if you just click on the page, it does load up, and you can click on the individual cards and they can still have the state as we described before. So you can change states and everything works perfectly. Okay, when React builds a list like this, it wants a key. So key is basically a unique label on each item. So it needs to be able to tell this item apart from this item and apart from this item. So for example, if I wanted to get the second item of this index or this list, I need to be able to exactly tell what makes this one unique compared to this one. Now, of course, you could make category your key, but then again, you might have the same category for 2 different questions. You could make question itself a key, but this is quite long and it also might repeat somewhere. Even your answer might repeat somewhere. So you have to create a different field for key. But first of all, let me show you the actual error that we get. So if I put this here, and if we go to our browser and open up developer tools, so just right click and click inspect, and if you come over to console, we will be getting some errors. Okay, so the first error says an empty string was passed to src attribute. Okay, so this was because of our header. So right, we're returning an empty image tag right here, so let's just remove that, and this error should be gone. Okay, so that error does go away. But the error that I'm more interested in is the second one, which says each child in a list should have a unique key prop. Check the render method of app, see warning keys for more information. So you can open up this, understand this error, and then you can open up this link and you can read through this. So you can read through this why you need a key And it does tell you that keys tell React which array item each component corresponds to. So if you add other items or if you're moving around items, React needs to be able to tell what component it belongs to. So just add a key. You don't need to understand all of that technical jargon, just add a key. The way we do that is just add a field here that will be used as your key. Now I'll just put a field that's like ID. You could have roll number as your key, or you could have, email as your key. You could have different things as your key. I'm just going to put a field called ID, and I'm going to make ID 2 and ID 3. So the only thing that you need to regulate in your keys is that no two elements or no two objects. So this first object has the ID 1. So no other object in this entire list should ever have the ID 1. Only this object will have the ID 1. So that React knows whenever it gets ID equals to 1, it knows that it's this specific object. And inside your flashcard itself, the first thing that you need to pass before anything else that you pass, anything else, is always going to be key. Card is going to be key equals to, and then you'll pass card.id. Now again, this can be anything. It could be card.email or anything that you want, card.serial number. You might have an employee code, a module code, or a subject code or anything. But basically it has to be unique, and no other object in this list has to share it. And once we do that, and once we save it, if we go back to our browser and open up our developer tools and go inside console, you can see that that error has now disappeared. We currently have a key for each item, and this item is unique to the other one. And when we add other items and when we move around items, which we'll look at eventually, React exactly knows where to put what. Made a list like this. You might still be confused as to why we made a list and then did all this technical stuff to map it out onto our screen using flashcards. Well, that's because we can do something like this. For example, if this list is empty, right now, let me comment out all 3 items. So that's one thing. I can comment out any item to take it out. I get everything empty, right? Nothing else on the page loads. So I'm simply going to, if the list is empty, I wanted to show something like there are no items or there are no cards or some sort of message to show that it's empty. Like if you have emails, right? Or if you have a chat with somebody, it might show there are no previous chat messages, or it might show that there is no conversation history, something like that. It shows something when there's no data. So I want to show something when there's no data. Simply, that's called conditional rendering, which is the title of this section. So at the very beginning, after our header, right before we start our deck, I'm going to create a conditional render. So what a conditional render means that if certain conditions are true, then this thing will execute. If those conditions aren't true, then it won't show on the screen. So we'll do that. We'll create a paragraph tag, and we'll say, just for the beginning, we'll say initial cards dot length cards in your deck. So this is just for information. We're not at the conditional part yet. Let's look at our browser, and it says 3 cards in your deck. If we copy one to the other one and then we put an ID of 4 right here. Oh, you need to add a comma. Okay. If you put an ID 4 right there, it's going to say 4 cards in your deck. And the more you add, the more cards you get. And if you remove one, it's going to show those amount of cards. So that's also one advantage of using lists. Okay, so the second advantage, and the one that I wanted to show you with conditional rendering, is if there are 0 cards. So right here, if there are 0 cards, show this message. Show this message. So the message that I want to show is, I simply want to say no cards yet. Something like that, okay? So you insert JavaScript in here. You directly insert JavaScript. So every time I say insert JavaScript, you need to know that we're inserting curly braces, because inside this HTML-like syntax, to insert JavaScript, we always use curly braces. Okay, so inside here, I'm going to say initial cards dot length equals to 0. So triple equals to means it has to exactly match this with type and everything. Otherwise, something like, 1 is technically equal to 1 because they resolve to the same value. Also, true can equal to 1. False can equal to 0. So we have truthy, falsy values and such, but these can be true. These conditions will always be true. But when we use triple equals to like this, when we use triple equals to, 1. So 1 is, when we do this, we get false, because even the type, this is a number and this is a string. Even the type has to match. So if everything exactly matches, so if this exactly returns 0 and not something empty, then this condition will be true. If this condition is true, so I'm going to put a double and % here. If this condition is true, then I want to do something. So I want to create a paragraph tag. So I'll create a paragraph tag, and inside it, I'll say no cards yet. So this is pretty simple, right? Conditional rendering. It sounds complicated, but all you're doing is you're checking a condition. If that condition is true, you put a double ampersand and you show an element. So this element will never get rendered onto your screen if this condition is false, because this condition is going to return false. It's going to be false and true. But if this condition is true, then this gets rendered onto the screen. Now let's look at our screen right now. Let's look at it right now. We have 3 cards in our deck, so this never gets rendered. But if we remove all of our cards, or if we comment out all of our cards, we can see 0 cards in our deck, and we get that no cards yet message. Even if we have one singular card, it'll throw 1 card in your deck and it'll show that card. That message will be hidden. So every single card has to be gone. Every single card has to be gone, and it will show no cards yet. And if we have a certain number of cards, then simply it'll print out the number of cards we have, and it will show those cards. It will render those onto our screen. So we've made a live card count. And we made a message ready for the empty case. Now let's make this empty case actually happen. Right now, it only happens if I purposefully comment out all of this, but let's make this possible. So let's automate the process of this empty message happening with a button. So let's add buttons to add cards or remove cards so that we can actually see this message work. We have, again, we need memory. And what did we use for memory? Well, we imported useState from React. So inside flashcard, we have memory. And the reason why we need memory inside flashcard is to know if we're clicked on or if we're not flipped. Inside app, we can keep a memory. This memory is going to keep track of how many cards we have, or rather if we have cards or if we don't have cards. Okay, so to import memory, you'll get used to this. Anything dynamic that you want on your page, so anything that needs to remember something, anything that needs to do something by remembering or by looking or by checking, constantly checking, that is going to be using useState. It's going to be using memory. So I'm going to import useState from React. Simple as that. So this is our memory tool. Okay, and what are we doing? We're keeping track of the cards in here. So in flashcard, we had a constant isFlipped. So isFlipped kept track of if our card was flipped or not, and by default it was false. Remember, useState, it returns 2 things. One is the actual value of useState. The second is a way to change that value, and this is the only way to change that value. So we're going to keep track of how many cards we have right here. So inside our app itself, always you have to put this inside the component, by the way. It always has to go inside the component. So we're going to hold the deck in state so we can change it and have React redraw. So all I'm saying is the deck that we have right here, the initial cards deck that we have right here, we're going to hold it in state. In state means we're going to put it in memory so that we can change it and we can remember how many it has, and we can have React draw and redraw these cards. Okay, so actually I want to show you why we actually need memory in this case. Because for example, you have your initial cards, right? And at some point in the future, before rendering, by the way, before rendering, or let's say after rendering, let's look at both. Okay, so in some point in the future, before rendering, you want to add another card. So you want to render another card as well. So what you can do right here is you can do initial cards dot push. Dot push is a way to put elements or things into your list or your array. So I can do dot push and then put this card. So actually, I'll copy this and I can copy this like so and put it in here. So I'm going to dot push all of these items into my initial cards. And let's look at our page. Our page, oh, we have 3. Okay, so we need a new ID. That's why it gets confused. If you refresh this page, okay. Okay, so what I wanted to show you was that things break if you do it like this. So you have your initial card push right here, and you're pushing you're pushing this object onto this list. When you're pushing this object onto this list, we're getting it twice. Why are we getting it twice? We're getting the same thing twice because if I change this to something else, then you can see both of these cards change to show that reflection. Right, so this thing is getting pushed twice onto our initial cards. That is exactly why you don't want to do stuff like initial cards.push, or you don't want to change your array or list inside your components. You never want to change your list. Again, I repeat, you never want to change your list inside your component like this. Never. You always use something called hooks. You never do it like this. Never do it raw. The reason why we get 2 of these is because our app component is being called 2 times. The first time that it gets called, one card is pushed. So now we have 4 cards. The second time it's called, we have now 5 cards. So we get 5 cards right here. And the place where it's getting called twice is inside our main.jsx. So let me open up our main.jsx right here. And we can see that strict mode is being applied. So strict mode makes a call to our app once, and app itself gets called once. So if I remove strict mode, you can see it gets only pushed 1 time. If I add strict mode, then it gets pushed 2 times. So it's quite unpredictable. Whenever you add something into your component, raw like this, it's unpredictable to know what happens. So we never want to do this. We want to hold our deck in a state so that we can change it using our state. Our state automatically reloads our component for us, and we can control how many times it's going to reload. We can track where it reloads. So if all of that was a bit too technical, just ignore everything I said and let's move on from here. Let's move on from holding our deck in state so that we can change it. So we're going to do the same thing that we did in our flashcard. We're going to create the same syntax, but in this case, instead of having is flipped true or false, we're going to store the number of cards that we have. So we're going to do const cards, and we're going to do set cards equals to useState. We're going to use state, and by default, we're going to pass in initial cards. So initial cards is our list. So this is our list, or this is our array. And this array is, we can access this array by using the word cards. So if we use the term cards, then we can access this array and we can see what's inside it. If we use set cards, then we can change properties on this array. So we can maybe remove an item or add an item or clear the array or something like that. Okay, so now we have official memory of this array. We can change stuff inside it without facing consequences. So like so, we can do set cards, and inside set cards, we can do cards.push, and we can push this. So I'll copy this, and we can push it like so. So when we push it like so right now, and we come to our page, you can see we still, okay, so I'm going to use this memory to add a button. And when I click this button, I simply want to remove everything inside my array. So I'll create that button right here. I'll create it right above deck. So right here, I'll create a button, and let me open this up. So inside button, I'll name it clear all. And inside it, I want to insert JavaScript. So on click, so we've done this before. Whenever I click this button, I want to do something. When I click it, I want to execute a function. And this function is simply just going to use set cards and set it to an empty array. So this should make perfect sense to you because we have a button. The text that shows on the button is clear all. And on click event, so there's an event on the button. Whenever we click on it, I run a function, and all this function does is it uses set cards. So set cards is how we're keeping track of initial cards. Initial cards is loaded into memory by using useState, and set cards is the only way to change it. So we're changing that memory. So we're changing the memory that's loaded of this array. We're changing this array in memory to be just empty, literally just be empty. So if we go back to our page, now this has memory. If I click clear all, so if we press clear all, nothing changes on the page really. That's because we have a memory right here, right? Our memory is up here. Our memory is using state, and the memory is initial cards, that array. We're loading that array into memory, and then the way to access that array is using cards, and the way to change that array is using set cards. Now, the array that we have loaded into our memory is now living inside cards. And when we click that button, we're actually setting the value of that cards to be empty. Right, we're doing all of that. But why are we still getting data? Well, that is because inside our map itself, we're mapping initial cards. So we're mapping this original array instead of the array that we loaded into memory. So we loaded this into memory. We can only change the stuff that we load into memory. We cannot change this. If we change this, then things break. We saw earlier, things break. So we have to change the things that we load into our memory using useState. So instead of going through initial cards.map, we just map cards, because by default cards is initial cards. This is the default value, right? You remember the default value. Default value is the initial cards, and it gets stored inside the variable cards. And now when we press the button, when we press this button clear all, then we use set cards to remove everything, to set it to empty. Now, if we access cards, then it's going to be empty. This is the great way, this is the responsible way of managing state and memory in your React pages across your components. So now if I refresh this page, if I refresh this, I have everything. But if I click clear all, then all of them get removed. All of it literally gets removed. Also in here, we're saying 3 cards in your deck still, because initial cards, so this array right here still has 3 elements. Just the array that we loaded into memory was cleared. The actual array still exists. So instead of initial cards, we have to say cards, and we still don't get the no cards yet message because we're still checking initial cards, so we have to say cards again. And now we get 0 cards in your deck, no cards yet. But when we refresh, this use state memory that we allocated gets removed. We start fresh. So we start with our initial cards again. We start fresh. Now what's happening is use state is now using the fresh initial cards and setting that value. When we click clear all again, everything that was loaded into memory gets cleared because we ran this function. We ran this function where the array is now empty, and all of these things get loaded properly. So you can see every single time that we use set cards, so every time we use this set function or this set method, the whole function gets reloaded, or the whole component gets re-rendered onto our screen. Every time we touch anything, any of our memory using this, every place that we've used it, so every place that we use it here, we used it here, it gets reloaded so that there's no trailing memory. Like after this, only if only the flashcards got reloaded, but the length was still the same and this message wasn't showing, that would be broken, right? To prevent that from breaking, every time we use set cards, the entire component gets reloaded. And since we're dividing things into component, you can see header is also a component, but the header component is never reloaded. Even if something changed in header, we don't care because this set cards just reloads the component that it is in, which is the app component. I hope all of that made sense. This section was a little bit more technical since we're using useState. But if you go back through it, look through it a few times, try it yourself, try to add some new things, delete some new things, I'm sure you'll get it.
Okay, so currently we have our page and we have a few cards. And at this point, each of these cards are coming from an array. So we're pulling it from data that we create. And also each of these cards have use state for now. And we have applied props for questions and answers so that when you click on them, you get a question or you get an answer. But currently we're hard coding this array as well. So we're hard coding this array. what we're doing is we're manually giving in data for the array, and then we're taking that data and then making cards from it. Well, in this section, what I want to do is I want a box and its question, and I want a box and its answer. Then I'll have a button. Let's say I'll have a button right here, and this button will, for example, say add. And when I send this form, so this is a form, when I send this form, that specific question and answer will generate a card, and then the card will appear on the page. Okay, so first of all, let's talk about controlled input. Controlled input is React's state, and React's state is the single source for what's in the box. So you know what input is. We do input by using input elements inside a form. And the only way to know what's inside those input blocks right now is by using React state. So we're going to create a memory for the input, and then we're going to store it there, and we're going to change it there and stuff. So we'll look at this as well. We've talked about React state a little bit by using useState and how to allocate memory. Next, we're going to then tie the box's value to a state variable, and we're going to update the state variable every time the user types. So currently, this is how our page looks like. We have 3 different cards, but I want an input field right here where I can add a new card. So I'll come to the very top, and this is where I've created one state. This state this state held our initial cards array, and we could access it using cards, and we could modify it using set cards. Similarly, we're going to create a state. So we're going to create a state to hold whatever the user types for the question. So we're going to do that by creating a state for question, and the way to change it is going to be set question, and we're going to use state, and the default value would be an empty string. So we created a memory with an empty string. The way to access this memory is by using question, and the way to change this memory is by using set question. Okay, and inside here, right after a header, I want an input field. So I'll do an input field of the type text. Type text is fine for now. I'll format this a little bit. Okay, so right after type text, I want a placeholder. So placeholder is whatever will be shown inside the box when you're not typing. So placeholder will be question for now, and its value is going to be question itself. So currently its value is going to be empty, but as the user types, we're going to put a value inside this field so that we can access it later. Okay, so onChange is a property. OnChange is a property or an event. Let's say it's an event. So if I hover it, you can see that the change event is fired for input, select, and text area elements when the user modifies the element's value. So whenever you start typing inside our field, our onChange is going to trigger. Every time you type E or R or you press backspace, that's a change event. So when we change, what do we want to do is we want to pass this event into a function. And this function is going to use the set question. So it's going to use set question to set the value of this memory to whatever the user typed. So we're going to set it to e.target.value. Okay, so this is a pretty solid and a pretty common way of storing text inputs in React. So first you need a state variable. So you need a state to hold the contents of that input. So in this case, it's our question. So we need a state to hold that question. The second thing you need is the actual input itself. And the third thing you need is these 2 things. So the value of it has to be the memory that you allocated earlier. And onChange is whenever the user types something, this is going to get triggered. And you have to set the value of whatever is inside that box. So you use E, and then you set it to set question e.target.value. You use set question to change this memory to whatever the user typed. Now, if you head on to our page, you can see that we have a question. And you can type in here, you can type whatever you want in here, it will show. But currently, if we access the value of this element itself, it's going to show coded because we set its value. Now, one thing you have to remember is if you don't set this value, you can still see the typing. So you can still see that I'm typing coded. But the value of this box or the value of this input field is going to be empty because we're not setting the value. So you always have to set the value so that you can access it later on. And now we have the question. So we're going to do the exact same thing, but for answer. So like try it yourself, just do the exact same thing, make a state and then put an input box for the answer. Okay, so I'll do it now. Instead of for the question, I'll say for the answer, and this will be answer, and this will be set answer. Next, I'm going to take this input, and then I'm going to copy it down. But in this case, the placeholder is going to be answer. The value is going to be whatever the value answer has. And we're going to set the value for answer instead of setting the value for question. And now, after doing all of that, you should have a field for answer as well. So you have a question field and answer field. Now, the only thing you need is a submit button that is going to generate a card. So first of all, before that, we actually need to wrap these inputs in a single form so that React knows that this is one singular form. So I'm going to create a form like so. I'm going to put a space right here, and I'm going to take this input field and I'm going to cut it and paste it inside this form itself. Okay, now the form has a special property that I want to use. That's why I did this. But before that, let's add a button. So let's go to a new line and add a button. So this button is simply just going to say add card. That's all it's going to say. And the type of this button. So type is a special attribute that this button has. And this type is going to be submit. What this means is that whenever I press this button is going to send a submitted event to this form. And inside this form, I can check if the button has been clicked by doing on submit. So on submit is going to constantly check if our button is being clicked. As soon as we click our button, we get the on submit event. Now, when we get this event, what do we want to do? Well, we want to add a card. Now, writing all of the logic for add card inside here itself would be kind of lengthy. So I'm simply just going to say add card. Now, this event or this function, this method is not defined. So hover over it and simply click on create function add card. And let's make it top level function. So I simply created a function add card before our app component. And inside this add card, what we want to do is, first of all, we need this event. So we have to pass in the event, right? Because you need to know what's happening. Now what you do is event.prevent default. So event is the actual event of clicking. So event is the on submit event, is the submit event. What you do is you do event.prevent default. So by default, whenever you submit a form, the page reloads, the browser reloads. So this basically stops the browser's page from reloading when form submitted. Usually, whenever you submit a form, the browser reloads and all of the fields are refreshed. So we don't want that. So we do event.prevent default. Now, what we want to do is build a new card object. So you know objects by now. These are all objects, key value pairs objects. So you want to build a new card objects from what the user typed. And next, we're going to do date.now, which gives us a unique number. So why do we need a unique number? Well, of course, ID is a unique number, but you might slip up and use the same ID twice. Whereas date.now is basically the time and date that the user clicked submit. So date.now will always, no matter what, this will always be unique. That is why we're going to use it as our ID for our new objects. So what you want to do is we want to create a new card. So I'll just name it const new card, and it's going to be an object, right? Now, what properties did we have earlier? We had our ID. So ID is going to be date.now. Then we had our category. So category is going to be custom because the user just added by themselves. We could have a field for category as well. You could add a different field for category. And this is something that I actually want you to do. So simply create a new state for category and set category. Create a new form. Actually, inside the same form, just create a new input element. And inside this element, set the value to category and set the on change to trigger set category. And over here, instead of saying custom, you can use whatever the user typed by simply just passing it. So the question is going to be question because we have the question passed through here. We have it passed through here. And the answer is also simply just going to be answer. Now I've noticed that question and answer So these variables or these qualifiers are outside because we've defined those states in here, right? The question state and the answer state are defined inside here. So we actually want to take this function. I want to take this entire function and put it inside app. So right before returning, put it inside the app so that we can access this question and this answer. So you can see why we need question and answer, right? Because these will set the question and answer on the top here. So now any function inside our component can easily access that question and answer. And that is our object. All we needed was an ID, category, a question, and an answer. So what is the next thing that you need to do? Well, the next thing that you need to do is actually add this to our cards. We want to add it to our cards so that when we initialize all of our cards, when we cards.map, so like when we look through all of the cards, our new card is added onto that. So to add it to our cards, we're going to use set cards, which is, the only way to add a new card. You know this by now. We're going to do set cards, and I'm going to use something called a spread operator. So I'm going to do ... cards, comma, new card. So set cards directly changes the value of a copy of this list or array that is loaded onto the memory. Well, if we directly just pass a new card, what will happen is everything will get overridden and all that will be left inside it will be new card only. But using the spread operator makes it so that all the previous cards, are put at first and then new card is added on top of that. So spread out every existing card, and then we add new card. Right after that, what we want to do is we want to clear the input fields. So we want to clear the input fields. So I'm going to set question and empty and set answer to empty. So basically these fields are question and answer, right? They're question and answer. But what I can do is I can use set question and set answer to simply make the values of question and answer empty so that I can clear out the field when I submit. So let's go to our page now. And inside our page, if I refresh it, I have a question, an answer, and an add card. So inside the question, let's just add a duplicate question for now. So what is the red planet? What is the red planet? And the answer is Mars. So I can add this question. And once I click on add card, this card is added right over here. I can see the Mars field did not reset. I wonder why. Let's go on top here. Oh, it's because we cleared only set question. So we have to clear set answer as well. And I can do that like so. And if I refresh this page, this card will go away because we haven't saved it so that it can survive a page reload. But inside question, I will go ahead and do what planet is the red planet again. And for the answer, I'll put Mars again. Now, when I click on add card, both of these fields are empty and our custom card is added. And when I click on this, you can see that it works like any other card. Because now let's try it without the spread operator right here. So what if we just did set cards? So we created a new card and the card is as the ID of day.now, category custom, and the question is simply what the user typed by accessing this question state, and answer is what the user typed for answer. What if we just did set cards and then passed in that new card and cleared the input fields? Well, what would happen is if I type in any question and if I type in any answer and click on add card, you can see all of our cards got removed and just that one card got added because we didn't save the previous cards. To save the previous cards, you have to do ... cards because currently cards has all the previous cards. We spread those and at the end we add the new card. So like so, now you can add new cards to your application. So the last thing I want to do for this section is actually some error handling. Right now, let's go to our page and what's one possible error that we can have by adding this function? Well, it is that if a user just clicks add card without adding a question or an answer, a new card will be created with an empty question and an empty answer. You can see we just keep getting new cards and these new cards don't have a question or an answer. If you click on them, nothing happens and it just lets us do that. I can clear all and I can refresh, it'll go to default, but it just lets us do that. I want to prevent that. And it is simply a one-line guard. Inside our add card event, all we have to do is check. We're going to check if question and the answer field are empty. So the way to do that is if question equals to empty, or answer is triple equals to empty, then return. All return does is it immediately exits this function. So it never gets to create a new card and it never gets to set cards. Okay? So if either of these are empty, we're going to return. And if I go to my browser now, if I click on add card, nothing happens. But note another thing. If you press space a bunch of times here and I click on add card, a card still gets added and it's still empty. Well, that is because a space isn't exactly like this. A space would look something like this. Since you cannot possibly account for all the spaces that the user types, JavaScript gives us a neat function called trim. So you can simply do .trim and .trim. .trim basically just removes all the blank spaces. So removes white spaces from both ends of this string and returns a new string without modifying it. So if I come to my page now, and then I add a bunch of spaces and click on, I need to refresh it. So if I add a bunch of spaces and click on add card, you can see that the card doesn't get added even though there's spaces, because trim removes all of these spaces, and once they're removed, they match this condition. Okay, before I let you go, if you've understood all of this, you can move on to the next section. But if this was all a bit fast-paced for you, I'll explain what we're doing again. So we have a question and we have an answer field. When I click on add card, it creates a new card. The way we're doing that is, first of all, we need a state to hold the question and we need a state to hold the answer. We set the values of this state to whatever the user typed by doing onChange. Whenever we're changing anything inside the field, whatever we changed it, we're going to set the state. So we're going to set that variable to whatever the user changed it to. So target.value. Similarly, even in answer, we're doing the same thing. As soon as we call set question and set answer, you'll notice that the page or the component gets reloaded or re-rendered onto the screen. Okay, we're doing set question and set answer. Finally, we have a button. The button is of the type submit and has the name add card. Whenever we click add card, it's going to set a submit event into this form. This form is going to detect that submit event and it's going to call the function add card. This function is going to be called with the context of event. Event.prevent default, all it does is it prevents the page from reloading whenever the user presses submit. Then we're checking if either the question or answer were empty. If either of them were empty, we don't want to create a new card. If they're not empty, then we continue on and we create a new card. The new card is basically an object like how all of our other cards are. It's basically an object with an ID category and question answer. For the ID, we're using date.now so that we don't have conflicting IDs, because if you have the same ID, React gets confused. So we need to have different IDs. Date.now simply returns the date, and date is always new and unique for every element. Category, we're just setting it to custom. You can try setting your own category by using state. And we're setting the question and answer to the question and answer that we have saved right here inside the state. So the question and answer. Simply after that, we're going to set cards. And inside set cards, we're going to put all of the previous cards we have plus the new card. Now, as soon as we call set cards, React notices that the value of this memory has changed. So it redraws the entire component for us. So we don't actually have to redraw the component, but as soon as we do this, it redraws the entire component for us. Then set question will redraw that question field and set it to empty, and set answer will redraw that answer field and set it to empty. And that is how we have a working system, how we can add cards with some basic error handling. Currently, this is our application. We have a question, we have an answer field, and we have a bunch of cards on our screen that we can edit and look at. Okay, but what if, to get these questions from somewhere else? For example, maybe you have a database, or you have, in this case, a server. And the server has a bunch of questions and a bunch of answers. And you want to take the questions and answers that this server has, the server will provide to you, and you want to put that inside your page. How are we going to do that? Well, that is where we're going to use effect, and we're going to use fetch. So fetch is for storing data, and useEffect is a hook, a React hook that we'll be using to run specific code when the app loads. So when we are getting data from a server, there are three things that can happen. One is we are in the loading state. Loading means we're still fetching data. One is we're in the failed state. Failed means we failed to fetch data. And one, we're in the success state. Success state means data has successfully been retrieved from the server. So we have to save these states inside our application, because while loading, we want to show maybe a loading or a spinner. If it says fails, we want to show an error message. And if it says success, we want to load the cards, right? So we'll be going over that in this section. So before anything else, I want you to understand one key term, which is called a side effect. So what is a side effect? Side effect is basically anything that a component does that is not drawing itself on the screen. So the main purpose of a component is to draw itself on the screen, right? Like our app component is drawing a header, a form with input fields, and it's drawing a paragraph, it's drawing a button, it's drawing a div and stuff, right? So all a component does, so the main job of a component is to draw itself onto the screen. A side effect is anything aside from drawing itself on the screen. So maybe like talking to the internet, maybe fetching data, if our component is fetching data, if our component is setting a timer, or if our component is reading the browser. So we'll look at this later. So a component can look at cookies and local storage and stuff. So we'll get into that as well. So anything that a component does aside from drawing itself on the screen is a side effect, which includes talking to the internet, fetching data and stuff. So the one we'll be looking at is fetching data. Fetching data from the internet is also a side effect. So for example, you have a database somewhere with a bunch of question and answers, and you want to load it into your application right here. So your component in that case would have to fetch that data from your server, which is a side effect, okay? So React actually gives us a special tool to run these at the right moment, to know when to run these, and that is called the useEffect. We're going to use this hook. So anything with the name use and something is called a React hook. So what we looked at right here, useState. useState is also a React hook that allows us to access memory. useEffect is a special tool to run side effects at the right time. What we want to do is we want to fetch our cards only once. As soon as the page loads, we want to fetch our cards. We don't want to continuously keep fetching our cards, right? We want to fetch it once, right when the app first appears. So we're going to handle how we're going to do this by using useEffect, okay? So to start using useEffect, similarly how we imported useState, I'm going to import useEffect. All right, it's now we're using useState for a memory tool, and we're going to use useEffect for managing, let's say managing side effects for now. Managing side effects. Okay, now to set it up, you do it exactly how we set up our useState. useEffect will also works in the same way. In fact, all React hooks work in the same way. So I'm going to create a const for cards and set cards, and I'm going to use state empty. Before, what we did was we had our own cards. So we use state and then we use the cards that we have already. But right now, we don't want any data that we already have.
So I'll remove this and I'll remove this. What I'm doing now is I'm going to create an empty array in memory to hold our cards. Okay, previously we already had an array and we loaded that onto our memory, but now I want an empty array to hold our cards. So if I go to our page right now, our page will have no cards because we're loading an empty array. Okay, and we want to fetch data from the internet and put it into this empty array so that it can be loaded onto the screen. Now, there are a few things that can happen when we're fetching data. One is, are we still waiting for the data? If we're still waiting for the data, we need to keep track of that. So we're going to create a loading and set loading state. So we're going to use state, and by default, it is true. By default, we're loading. By default, we're trying to get data because we start with an empty array and we're getting data. Next, we want to check if we got an error. So did it go wrong? Did it go wrong when fetching data? So for that, const is, we're going to say, let's say error and set error. By default, useState is going to say that we didn't get an error. By default, we don't have any error. But if we do have an error, then we're going to set error to set an error. So all I changed right here was now our cards are just empty. Our cards point to an empty array, and we can use set cards to put items into that array. We have another useState for loading. By default, loading is true, and we can set loading to set loading true and false. And the last thing is error. So by default, it is false because you have no errors by default. Now, the next thing that you need is the actual skeleton, the useEffect skeleton. How do we use useEffect? Well, what does it do? It runs the code inside after the component first appears. So for the first time that the component appears, after it has appeared, it runs whatever code it has inside it. Okay? So we're going to do useEffect, and it takes two arguments. The first is the code that it needs to run, which is going to be inside a function. So effect, the effect that it's going to have. It runs a specific code inside after it appears, right? So the code that it runs is going to be inside here. Next, we give it an empty array. So empty array, you can see it says DEPS, which is dependencies. All this does is, I'm going to write it right here. The empty list at the end means run this on the once on load. So as soon as we load the page, I want to run it only once. Anytime you want to run it when something changes, you'll add it to this array right here. But right now, I just want to run it once. And this is your total useEffect skeleton. So it is a function. Inside the function, it has two arguments. The first argument is another function, which contains the actual logic that you want to run. And the second argument is an empty array, which basically means run it only once. Okay, now for our loading screen. I give you a way that we can check or we can put a condition on whether a thing shows on our page or not. And the way we did that was using simply these and symbols. If the card's length are 0, we show no cards yet. So this is a condition. A condition, when something is true, then you want to show an element. We want to render an element. If it is false, we don't want to render that element. So we're going to do the same thing, but for loading. So right here, we're simply just going to say, while waiting, show this. And the way we're going to do that is loading. So the value of loading by default is true, right? As soon as we load the page, the value of loading is true. Set loading, the useState, it's true by default. The only place where it becomes false is after all of our cards are loaded in or if we get an error. So until our cards are loaded in and until we get an error, we want to show that we're loading the data. So we're going to make a paragraph tag, and all I want to say is loading data. Right? Now you can make this look pretty and all, that's not our concern for now. For now, I'm just teaching you the functionality. You can show a loading screen. So you might, instead of showing this element, you might show a screen or a cursor or a blinking something or like a spinning something. And you can do this, okay? And error. So if we failed to get data, show this. So simply to do that, error. By default, error is false.
So this element won't render by default until and unless we manually set error to true. So could not load cards, try refreshing. Okay, the only place where we're setting error to true is if we fail to get data inside our catch block, set error to true. So if I go to my page now, and we've made this pretty advanced by now, so it says could not load cards, try refreshing. So we've errored. And if I open up our console, we can see that we've errored by a response code of 429. So the reason why you get 429, and you can Google this, so status code 429, it is when your API is overloaded. So if you send too many requests at the same time, your API will rate limit you and send 429. So if you refresh too fast, you get 429. Now if I refresh, it says loading data while we're loading data, and it shows all of our data like so. And we're still getting an error, it seems like, inside our console. So we're still getting 429 because I've made a lot of requests in the past minute really fast. That's where we're getting this. But if I load it pretty fast and we don't get a data back, it says could not load cards. But if we do get our data back, the loading screen goes away. We still get this because our API is returning error. So this is not something that we can fix because the API itself is sending an error and the data at the same time. So this is not our concern. Inside our network tab, let's look at it. It says too many requests, but in response, it is sending data. So I don't know what's happening with the API. This is an API related issue, but on our end, everything works perfectly fine. Okay, now let's talk about fetch. I'll write it right here. We're going to use fetch. What is fetch? It is the browser's built-in tool for asking a website data, Anytime you want data from a website, you're going to use fetch. Well, it is a built-in tool. Later, we'll look at Axios as well, or maybe I'll make a different advanced video to talk about Axios. But what happens is the data, anytime you send a request for data, the data comes back as a JSON. So I'm sure you're familiar with JSON, but JSON is like a text that looks like object. So it is something that looks like objects that we had before, but it's not exactly an object. So it looks like this, but it is not this. You have to convert it into a JavaScript object. Okay, so JSON basically just stands for JavaScript Object Notation. You have to actually convert it to a JavaScript object to use it. Okay, so for this purpose, we will use a free trivia API. So we won't create our own API for now. We'll just use the free API. And we're going to put all the API, we're going to call the API for questions and answers, and we're going to use those. Okay, so inside useEffect, the first thing we're going to do is we're going to fetch. So I'm going to fetch this URL, so https open tdb opentrivia.com/api.php amount equals to 6. So I'm going to call in 6 questions and answers, and en code equals to URL 39. So you can just copy this link. I actually want to open it in the browser and see what we get first. So if I open it in the browser and make sure you're removing the quotations, you can see that we're making a request to an API. And what this API gives us is it gives us a JavaScript object notation, so a JSON file. And inside this JSON, we have 6 different trivia questions. So if I put, like, instead of 6, I put something like 60, it would probably give us 60 questions. Like so, it would give us 60 questions. So right now I want only 6. And you can turn pretty print on and see these questions. Okay, so this is of the type multiple. Difficulty is easy. Category is entertainment and video games. The question is, what is Call of Duty Black Ops based on? And the correct answer is Cold War. And we have a bunch of incorrect answers as well. So this is more of like a multiple choice question kind of thing, but we can easily convert it into our study deck because all we need is the category, the question, and the correct answer. So we're going to only concern ourselves with these 3 properties. So we can take these 3 properties and then create an object out of them, put that object inside our cards, and our page already has the loading cards function. So first of all, as soon as we fetch dot then, right? As soon as we fetch, The dot then runs only if the fetch is successful. If the fetch is successful, we're going to take the data. So the data that we got, this is the data that we got. And what we're going to do with the data is, first of all, we're going to convert them into our card shape. So before we actually do that, the data that we get right now is actually a response object. This is a response object. We actually have to take out this response code 0, and we want only what's inside the results, and we want it in a format that we can use. Right now, it's not in a format that we can use. So before we do this, right after we fetch, we take our response, so the response object. So this is the actual thing that we have right here. So all of this is the response. We need to first of all convert it into a JSON. So response.json. Simply converting it into a JSON file so that we can actually use it. Actually converting this JSON file into an object so that we can actually use it. So this is unusable because you can see it has double quotations here and here as well. But in JavaScript, when we use objects, we don't have double quotations on both sides. We have it only on one side. So on the right side, on the value side, we have double quotations. On the key side, we don't have it. So to convert it, you simply just call the function. You call the function response.json, so it converts it into a format we can use. Then we now have data. So after converting it into a JSON, we send it to the next dot then, which now has the data. What are we doing with the data? We turn it into our card. So we turn each item into our card shape. Okay. What we're going to do is const loaded. So we're going to create a variable called loaded, and simply like we mapped our cards right here, we did cards.map so that every single card item would be mapped. We're going to run another map function. Our map is going to take all of these one by one, right? So I'm going to do data.results.map. So data.results, because first of all, we have response code and results, right? So data.results goes inside this and then starts mapping all of these one by one. So this comes first, this comes second, this comes third, and so on. You get the point. So dot map, and we're going to get item and index. So index is the position of this item. So you can see that the index of this would be 0, index of this would be 1, index of this would be 2. And inside the item, we get the actual item itself. So inside the item, we get this entire object, and inside the index, we get 0 for first, and then the second object, 1 for second, and so on. So our ID is going to be the index. So the position, actually, instead of simply doing like so, you actually need to pass in small brackets here as well to create an object. So our ID is going to be index. So this would have the ID 0, this would have the ID 1, 2, 3, 4, 5, and so on. Our category is actually given to us right here. So we have a category field right here, okay? Category is going to be decode URI component and item.category. So inside item, remember, inside item, you have this whole item. So item.category would give us this value, but you can see this value has these percentage signs and everything else like numbers right here. And that is a URI component. Simply doing decode URI component makes it into a human readable language. Okay. Next, I want you to get question and answer yourself. So how would you get question and how would you get answer? I want you to do this yourself by looking at this response. The question is inside the data that we have. And of course, you would need to decode URI component on this as well. Okay, so I'll do it. You do decode URI component and simply item.question, because this is our item. Item.question would give us this value right here. And when we decode URI component on that value, you get the actual human readable syntax. Next, for answer, you do the same thing, but instead of item.question, you do item.answer. Now we have an object, and this object is in the exact same syntax as what we expect right here. We need a category, a question and answer, and an ID. And now we have category, question, answer, and an ID that we took out of this response. So we made a fetch response, we made a request to this API, which gave us a bunch of stuff. we looped through all of the results. And then we pulled out category, question, and answer and created an object out of them. Now, after we create an object, so if we successfully create an object, what I want to do is now I want to change our state. So I want to change a bunch of states. I want to set cards to loaded. So set cards changes right now. Currently our cards is empty, right? But I want to set cards to loaded. Since loaded is an array. Loaded is an array of all the cards. So we map through all of the cards and put it into the variable loaded. So by the end, loaded would go through this. It would get the ID of 0, since we used index. It would get the question, correct answer, and the category. Then it would move on. It would put this at the ID 1. It would get the category, question, and correct answer, and move on. And by the end, loaded has 6 different objects with all of these in the format that we need. Okay, and simply set cards loaded takes all of the data that we got and then puts it into our useState memory that points to cards. So now we can use cards and then we can access this thing that we converted from the API. Okay, right after that, I want to set loading. So since by default loading is true, now that we've loaded everything, I want to set loading to false. By default, our value for loading was true. I set it to false. The reason, you'll see why we're doing this, because when the cards aren't loaded, so this might take some time actually, this takes some time to happen, because even in this page, you can see that when I refresh, it takes some time to get the data. You see, it takes a few seconds before the data comes out. Oh, it takes a few seconds before the data comes out. So during those few seconds, our loading is true. And we want to show something on the screen while our loading is true. After we get our data, we set loading to false, and then we remove that component. And finally, you need something. So after all of our .thens are finished, you need a .catch block. So .catch simply does what it says. It catches any errors if it happens. So we might get an error while fetching the data. We might get error while converting it. We might get an error while mapping it. So any error that happens, we simply catch it. We catch that error and we set error to true. So if our set error is true, we want to show something on the screen. And set error is simply another state that we have right here. We set error to true and we set loading to false. You must set loading to false, because even if you got incorrect answer or if you got an error while fetching data, you're officially not loading anymore because you already loaded and you got an answer. It's either the correct data or the wrong data. If you got the wrong data, you set error to false. If you get the correct data, you set cards to loaded. But in both of those cases, you have to set loading to false. And now as such, we can now go to our page and we can go right here and we can refresh this and we can see we got a bunch of data. So you can see that we don't get the data immediately, and while we don't get the data, you get 0 cards in a deck, no cards yet. But in the background, our set cards is setting it to loaded, but our loading is true, right? While we're still waiting for the data, our loading is true. So instead of this, we want to show maybe like we're loading data or something. And if we get an error, so I think we just got an error here. That's why we don't see anything on the screen. If you go to your console, you can see the error. You can see the error if you go in the console. But right here, we don't know if we errored or if we got the correct data. So we also want to show if we errored right here. So if I refresh this, we get our questions. Let's look at one of our questions. So you can see the category is loaded properly. You can see the question is loaded properly. And if you click on it, you're getting undefined for all of the answers. I wonder why you're getting undefined. Let's troubleshoot that. Our answer is decode URI component item.answer. Let's look at our response. In our response, we have category question. Oh, this is the error. The field's name is correct answer and not answer. We're looking for something that doesn't exist. Answer doesn't exist. The only thing that exists is correct answer. So if I change this to item.correct_answer, we should be getting this field now. We should be getting the value for this field. Okay, and I'll save this and let me go to our page and let me refresh. So now if I click on this, it should say the correct answer. So how many times do you fight the imprisoned in the Legend of Zelda Skyward Sword? If I click on it, 3. So I did get the answer. And you can see for all of the other questions, I am also getting an answer. And all of my cards are working properly. Now, for example, you wanted 50 cards, for example. So simply right here in the URI, instead of saying 6, you can change this to 50, and all 50 of your cards will load without you having to create new elements. Throw back to when I said we needed data like this instead of making elements for each question. See, now that we have made data like this, we can simply add items into that array, and our entire application will load that for us automatically, handle everything for us. So if I say 50, and then now I load this page, it will try fetching 50 different cards. You can see that it fetched 50 different cards, and you can click on any card and get the answer for that card. And you have a bunch of trivia questions inside your card like this. But right now, there's an awkward moment. It's all blank when it's loading, and I want to fix that by showing something, okay? Also, the clear all should work.
Okay, right now we've made a lot of changes, but if you look at our app file right now, so our app.app.jsx, what you'll notice is that it is too crowded because we have a bunch of things in here, right? We have our fetching logic, we have all the logic for our cards, we have all our loading logic, all of our error logic, basically everything, all the logics related to cards. So all the logic related to cards are living inside app.jsx right now. And what if we wanted to implement a new feature? Well, all of those new features logic would also go inside app.jsx. Well, that would make it, well, not nice. It's hard to debug, it's hard to look at things. So what we're going to do is we're going to make our own custom hook. Now we've looked at hooks before. Anything in React that starts with a use, so use state is a hook, use effect is a hook. And every hook gives us some sort of functionality in React. So useState is the one which gave us memory. It gave us a memory slot, a way to access it, a way to change it. useEffect let us load something for the first time onto the screen. So it made something happen as soon as we loaded into the web page or as soon as we loaded that component. Okay? So we're going to make our own hooks. We're basically going to scoop all of this out. We're going to take all of this, take it out of app.jsx, and then make it into its own reusable box by making a custom hook. App gets lighter, and the neat part is that we can use this feature over and over again anywhere. So we can reuse this hook anywhere, not just inside cards. Now this might be a little bit complicated if you're listening to it for the first time, but overall, topologically, just understand that all the logic that we have inside our app right now relating to cards, we're going to neatly package it into something, and it's called a hook. And we can use this hook wherever we want to re-implement this card logic on whatever page we want. So right now, the first thing that we're going to look at, or the first thing that I'm going to write, is a custom hook. Okay, so we can see that when we want a side effect, and it's basically anything that a component does that is not drawing itself on the screen. So when we did this, we used something called useEffect, which is a React hook. It is a special tool that does something, right? And even inside our useState, it's a special tool, or it's a state that holds whatever the user types for the question or holds whatever we want it to hold. And we can access it throughout our component, and we can change it using the special variable that it gives us to change it. What I'm saying is React hooks like useState and useEffect that we imported from React right here, they're React hooks, and they give us special abilities. useState is a memory tool, and useEffect is something we use to load something the first time our component loads. We're going to create our custom hook. Basically, our custom hook is going to manage all of our fetching. It is going to maintain the card state. So card state as in whether it has been flipped or not, the question and answer on it, the loading, the error, and useEffect. Since useEffect is already a hook that we use for all of our logic. So if we're creating a new hook, a new custom hook, then we need to put the useEffect hook inside it as well. We're going to embed that hook into it, okay? So that our app.jsx can simply import and use it. Why we need it, we're going to create one. So simply go to your project right here, just open up your Explorer, and inside source, we're going to add a new file. So this file is just going to be a plain JavaScript file. We don't need JSX inside it. Since we're just using plain JavaScript, we don't need to use HTML inside it. Okay, and then I'm going to name it use cards. Remember, all of your hooks need to start with this use keyword. So I have a file, usecards.js. If you're using VS Code, then you have to manually add that extension. Since our hook uses both useState and useEffect, I'm going to import them first from React. So I'm getting these two things first from React because we need to use both of them. Okay, now we're going to create our custom hook. Custom hook is also just a function. It's a function starting with the keyword use, as you might have surmised, that bundles reusable logic. Remember, our component itself, a component is a function that returns a piece of the screen. So it returns some HTML, and it always has to be inside one singular element. Remember, revise this often, it always has to be inside one singular element. Whereas our custom hook is a function that starts with use, and the purpose is to bundle reusable logic. Like useState and useEffect are default or things that come with React on its own out of the box, but we can create our custom hooks as well. So what I'm going to do is I'm going to create a function called useCards, okay? And inside this useCards, I'm going to have the logic. So simply from app.jsx, the logic that we had inside here, I'm going to copy this. So the first thing I'm going to copy is create an empty array in memory to hold our cards, because that's the first thing we need, right? This is the first thing we need. We need our cards, and we need to be able to set our cards. After we have our cards, let's add our loading state. Are we waiting for the data or not? Let's go about this one by one. Next, we need to know if there's an error. So let's copy the error. Don't worry, I'll copy the question and answer later on. We don't need them right this instant. And right after this, I'm going to pull in our logic. So simply, I'm going to pull in our useEffect logic. I'm going to take this and I will copy it and I'll simply paste it here. So we have our card memory using useState. We have our loading memory using useState, and we have our error memory. By default, our cards are empty because we fetch them from the internet. By default, we are loading because as soon as we open the page, we should go into loading until we get our cards. And by default, we don't have an error. We only get an error if we fail to fetch data. And inside the useEffect skeleton, inside the useEffect, we're fetching. Then we're converting that response into response.json, so into a JavaScript object that we can understand. Then JavaScript object is returned and we get data. So this .then statement gives us a JavaScript object. This .then statement captures that JavaScript object and passes it as an argument to this inner function. And what this inner function does is it creates an object. So a lot of objects, right? Because everything in JavaScript is an object. It creates an object by mapping every single item inside our response.json. So inside data, remember saying response.json and saying data is the same thing because response.json gets passed on to .then and .then passes it on, renaming it to data. So data.results.map. So inside data, we have two different objects, and the second object was results. Inside results, we had our questions, right? .map. So we're mapping those by item and by index. Item gives us the entire item or the entire object, and index gives us the position of it. We set its ID to that index, and then we pull the category, question, and answer out of it. So we've done this before. If you're getting confused in this, then you should go back to the previous section. And if you've understood this, then I'm pretty sure you've already skipped this section. Okay. So then we set the cards to loaded. So all the objects that we loaded into memory, we set it into cards. So all the objects that we loaded, we set it into this by using this useState, we set it into cards. Then we set loading to false because now we have gotten our data. And if we get an error, we set the error to true and we set loading to false. Okay, so far so good. And in the end, so since we've done all of these processes, but what does this function actually give? Well, what this function gives is it has to return a few things. So what are the important things that we need to return? We need to return cards, of course. Cards is where all of our data is, where the whole point of this was to get data from the internet and then put it into cards. Then we're going to export set cards so that you can change the cards, so that you can remove a card, add a card, or clear the cards and stuff like that. So we need to give a way to do that by giving in set cards. And we're going to export loading so that our app.jsx can check if our function is still loading or not. And we're going to give out error, so in case we encounter an error. And this step is basically going to be hand back everything. A component needs to use these cards. So for a component to find this function useful, the component should be able to access the cards that it creates. It should be edit the cards that it creates. So it should be able to edit the cards that it creates. It should be able to see if the cards are loading or not. And it should be able to see if we errored during the loading of those cards or not. Then we're useful. Okay, at the end, what we can do is similarly how we did it in every place else, we can export the function. So we can export default header like that. And we can simply just do export default, use cards. But instead of doing it like this, there's a shorter way. So at the very top in front of the function, I'll just write export. Since we're going to export this singular function only inside this whole page or this whole file, I'm just going to directly export it like this. If I had another function, I would also export it like that. Okay? Now, what are the two things that makes this a hook? Always remember, two things that make a hook. Number one is the name starts with use. Okay? And number two is it uses other hooks inside, and we return an object with everything app needs. It uses useState and useEffect. It uses useState and useEffect. And at the end, it returns an object. So curly braces are objects with everything our main file or our app.jsx needs. Now, app just asks that hook for cards, and we can set it like that. So inside app, we've deleted basically everything else. We've deleted the fetch as well. So I'll remove all of this, all of the empty space. And at the very top, what I'm going to do is I'm going to import use cards from usecards.js because that's where I made that file. And inside our function, before we do anything else, all I'm going to do is I'm going to get cards, set cards, loading, and error from use cards. It's as simple as that. As soon as we write this line, it's going to execute use cards hook, right? Inside use cards, we have a bunch of logic that is going to get executed. So all of this is going to get executed. And in live time, we can access all of these properties inside the object. And we can access them by simply importing them like this. And now everything else in our code should still work, because when we're creating a new card, we have a question, we have an answer. When we're setting card, we have access to the set cards, we have access to this cards, and everything that we need inside this file. And as we go down, we do also have this loading. So we have access to this loading variable, we have access to this error variable, so that both of these show or render properly. So if I open up Chrome and if I start this in development mode and let's browse to that page, you should see that everything should be exactly the same how we left it. So once you open this page, you can see this is my header section and all of our cards loaded properly. Now, if I were to double refresh this like that, it says could not load cards, try refreshing because we sent a request too fast. When we send the request slowly, we get all of our cards. And if you noticed earlier, we got an error message plus the cards as well because we were making 2 requests to the API. But in this case, if you reload the page, if you go into fetch, you can see that we're calling the API only once. Earlier, we were calling it twice. That's why one of them errored, whereas the other would give us all the data. That is because inside our app.jsx, if you put the logic of fetching inside the component itself, it runs it twice because of strict mode. And if I remove strict mode, like this, if I simply remove strict mode and then open up my Chrome again and go to that web page again, and if I look into the network tab now, we can see that we're fetching the API twice. One of them gives us a result and the other one fails because it goes right after the first. That's because the React, every time it loads a component, it renders it twice due to strict mode. That's where we're getting that. In production, you really won't have this problem, so you can safely ignore it. Normally, React controls the page for us. So it directly has access to the document object model of the page, and it manages everything that we put onto the page. We simply just give it JSX. But sometimes we need to directly edit an element inside the page, maybe to focus something, to scroll or measure something. So that handling is called a ref, which is created with the hook useRef. So inside app.jsx, okay, just follow along and you'll understand what I mean. Simply useState, useEffect, and I'm going to also import useRef and useContext. So I'm going to import these 2 extra things. So at the top, right here, let's start it. So what we're going to do at the beginning is create an empty ref. So we're referencing nothing. We're not referencing any element up to now, okay? We will eventually point it at a question input, okay? So we're going to create a const called question input, and it's going to be an empty reference. So you'll understand what references are very, very shortly, but they directly show or point to an element. Right now, initial value is null. It's not pointing to any element. Next, we're going to use effect. So when an app loads, put the cursor in the question box automatically. How we're going to do that is, remember, useEffect loads, the first thing that loads as soon as a component loads is the useEffect. So I'm going to start useEffect, and inside it, I will have a function. And again, dependencies is an empty array. Remember, this is the official formal syntax of useEffect. You should get used to this. And inside the function, what I'm going to do is question input dot current dot focus. So dot current is the actual input element. And dot focus puts the cursor inside it. So we don't actually know what dot current is right now, right? Because useRef is null. So you have to attach this hook. To an element. And we're going to attach it to our question right here. If I scroll down inside our question, right before type text, I'm going to give a reference. We're going to connect this box, ref equals to, and then I'm going to give question input. So now this box or this element is our question input. So question input references this box now, this input box. What we're doing as soon as we load the app, when this app.jsx loads, is that question input.current.focus. So our mouse cursor or our cursor is directly focused into the question input as soon as our page loads. You'll see what that means. Let's go to our page and let's open our application. And if we refresh it, you will see that as soon as we reload the page, don't worry about the bottom, but as soon as we reload the page, the cursor, so the blinking cursor directly goes inside the question box. So if you miss that, if I put this out, so if I comment this out, and if I refresh this page, you'll see that question is not highlighted by default. Nothing is highlighted by default. I have to click on question like so. But if we unhighlight this and I deselect, as soon as we load the page, the question is going to be highlighted. See, the question is going to be highlighted. So what we did was we directly referenced an element. So const question input, by default, it was an empty reference. It did not point to any element. But as soon as the page loads, as soon as this element loads, we say this is the element. So this is the reference that I want question input to have. So I want question input to point to this element. And useEffect, which is basically a hook that loads for the first time as soon as the page loads, all it's saying is that question input should be the current focus. So as soon as we load the page, the cursor should be focused inside that input box. Okay, it's a tiny touch. It's not much, but it's a tiny touch that makes an app feel professional. As soon as you load it in, you can start typing into the box. And it is a perfect example for when references are useful. You can use references for a multitude of other things. This is a small idea of how you can directly access an element by bypassing React. So that is the end of this chapter. What you can do now is you can bundle logic into your own hooks like this. Like we created a hook use cards, and you can bundle your own logic like this, to return an object, to take that object inside wherever you want to import it, and then call that hook or that function like so. So it's basically functional programming, but a bit more advanced and in a bit more React's way. And next chapter, we're going to solve a classic headache that most modern applications have, which is sharing data like a theme across the whole app without passing through every component. So if you have a theme, example, light theme or dark theme, maybe you want your app to have that same theme. You want your header to respond to that same theme. You want your use cards to respond to that same thing. So every component inside your application has to have the same theme. Now, how do you do that without specifically specifying it to every single component? So every time you call a component, you have to give it the theme. Well, how do you prevent doing that? How do you get across that? So that is when we're going to use context. So I'll see you in chapter 10 for that. Okay, our main problem, or the main thing we're going to tackle in this chapter, is theming. So theming is basically applying themes to your page. Now there's two ways that we can do theming. One way that we can do it is, let's just write out our structure right here. We have our app, and inside our app we have our deck. Deck is the entire thing, and inside that we have all of our cards. So it's like a tree-like structure where we have everything managed like so. And you'll notice in the previous section, this deck, we converted it into a hook, right? So all of that card logic was converted into a hook. Now, for example, if you want a theme would be at the top right here. This theme would be provided to the application. The application would in turn have to provide the theme to the deck, and the deck would in turn have to manually provide this theme to every single one of its cards, like so. And the way it would do this is by using props. So we know what props are. Props are a way to directly address an element. So from an element, you directly put an attribute and you can pass something into the component. So this is one way to do it. But this is quite messy. As you can see, every time that we want, for example, if you want this card on the bottom right here to have a theme, this card needs to get a prop from deck, and deck needs to get a prop from app, and app needs to have the theme itself. So a lot of things can go wrong when you have maybe 100 components or maybe 500 components. Every single thing in that chain has to rely on each other so that the theme doesn't break.
Instead, what we're going to do is, of course, we have that same topological structure. So we have our app, we have our deck, and we have our bunch of cards inside it. And let's say we have another component as well. So let's say C1 has another component with a bunch of stuff, C3 has a bunch of components with other stuffs. So all of this lives under the app itself. What we can do is we can wrap this entire thing in a theme. So we put a box over it, and this box has the theme. This box itself has the theme. So if anything inside the box, for example, if this component specifically wanted access to the theme, it could directly just grab it from this box because it lives inside it. If the app wanted the theme, it would directly just grab it from the box. If this component wanted the theme, it would directly grab it from the box because all of them live inside this theme, and the keyword is context. And that is what we'll be looking at in this episode. We'll be looking at context and how to create a theme context to tackle this very complex problem. So I'll repeat that problem one more time, and I'll write it at the bottom right here. And the problem was called prop drilling. So what we do here is we pass a prop down through different layers of components, some that might not even use it, okay? Because our app is at the top, our deck is in the middle, and our cards are at the bottom. For cards to be able to use theme by using props, our app would have to pass it to decks first, right? But maybe deck doesn't even need theme. Well, it has to carry that extra burden of passing on the prop. So that is one problem. And for something like a global theme, it gets messy, okay? Because all components need not have access to it. And if one component breaks in that chain, then the entire global theme breaks and it gets very bad. So what we want to do in this section is we want to learn how context works by making a dark and light theme. So we're going to make a dark and light theme that the header and the whole app both use. Now drilling would be a mess, context fixes it. And we're going to learn what context is by doing this way. I hope you've understood why we're using context and why we don't use props and what we're trying to do overall. Basically, we're creating a big box, which is our context, that anything inside that box can easily access. In this case, the theme. So for that, I'm going to create a new file. I'm going to create a new file for the theme. So inside my source, I'm going to create a new JSX file, and I'm going to name it theme context. So keep sure of the file notation. You can see everything that is a hook has a small use in the front, and all of our other component files have a capital letter, like a capital casing format. Okay, inside our theme context, we're going to import a few things. We're going to import create context so that we can create a context. I'm going to import useState. We're very familiar with useState by now. It gives us memory. We know this by now, but we don't know what create context is. So we're going to look at what create context is pretty soon. So create context makes the shared box. The box that you saw in the visualization at the beginning of this episode, it makes that box. Other components can read from this box. And in fact, they live inside this box. So the first thing I'm going to create is const theme context, and I'm going to create a context. Okay, this is our theme context. It is basically a big box. If you go in our main JSX, you can see strict mode. Strict mode itself is also a context. Okay, and our app lives inside it, and our app can access anything that is inside strict mode. Next, we're going to create a provider. Provider is what wraps our app and supplies the theme. And supplies the theme plus a way to change it. A way to change it. So we're going to create a function, theme provider,
and it's going to have a bunch of children. Okay, it's going to have a bunch of children. The argument that it takes is an object of children, and inside it I'm going to have theme and set theme. So this is definitely going to use state, and by default maybe I want the theme to be dark. Okay, so right now I've done nothing. I've just created a memory slot for theme. I can change the theme and I can set the theme using these two variables, and I'm using useState. We've done this a few times. What we're doing here is we're going to create a provider function. This function is going to wrap our entire application. It's going to wrap our entire application, and it takes an argument of a children object. So let's move on for now, and we'll look at what that means. So we're going to flip between dark and light. So we need a way to toggle our theme. So inside this function, we're going to have another function called toggle theme, and inside it, we're going to be able to change the theme. So set theme, and we're going to do theme equals to dark. So we're going to check if theme equals to dark, and we're going to use the ternary operator. If true, if it is dark, then we're going to set it to light. If not dark, we're going to set it to dark. So this logic should be pretty easy to follow if you know a little bit of JavaScript. We're using set theme to change the value of this memory again. We've done this a few times. If theme equals to dark, then we're going to set it to light. If this is false, then we're going to set it to dark. Okay, that basically flips our theme for us. Now, what we're going to do is we're going to create or define everything inside theme provider can now read theme and toggle theme if we do this. So children is whatever we wrap inside this provider. We're going to return a provider, and this provider is going to be theme context dot provider, and the value is going to be an object of theme and toggle theme. And we're going to end this theme context provider right here, and we're going to pass in children. So we're returning our provider. Inside this provider, we have children. Now we're going to define what children is. So anything that is in the place of this children has access to theme and has access to toggling the theme. At the very beginning, we created a context. A context is an empty box. We created a box that other components can read. So other components can read this context. Then we created a theme provider function, which takes in children. So which takes in a component or a bunch of component, basically children, basically components that we want to access this theme context. Inside it, we have a function to toggle the theme and our theme itself that is stored using useState. Then we're returning that provider, and inside that provider, we're returning the children with it. So every time we call this provider, it is going to wrap our children inside the provider, give us access to the theme, and give us access to toggle theme that we have inside here. And at the end, what I want to do is I want to export both of these. So I want to export the context itself, and I want to export this function itself from this file. Now we have a context and we have a provider, context provider, that are ready to use. Now we wrap our application in it and look at what it looks like. Okay, so we have our theme context and theme provider. This is the way to create it. It is a bit new, so you'll find it a bit difficult at first, but let's go inside our main.jsx and actually use it. So to use it, you have to import it inside your main.jsx. So I'm going to import it right here. Import theme provider from theme context.jsx. So bringing in our provider, and now we can use it. So to use it, simply after strict mode, we're going to use theme provider, and we're going to put our app inside theme provider. So what this does is now our app is the children. Inside theme context, if you look at it, our theme provider takes in a children. And in this case, our children is app and everything that app has inside it. In turn, our app has headers and everything inside it. So all of those now lie under theme provider.
And what can children do? Well, children can access this theme that we've defined right here, and the children can access this toggle theme function that we've defined right here. So any child can toggle the theme and any child can access the theme. So they can simply access it, see if it's dark or light, and make a decision on how to render on the screen. And all of this is given to us by the use of context, by creating a provider context. So every component inside our application at this point, so header, all of our forms, our cards, so all of our flashcards, all of these can now reach the theme. They can pull into the theme, check it, and change it. We provided it just once in main.jsx, and now everyone can access it. If we use prop drilling, then we'd have to manually give in the header theme like this. So we had to give in a prop and then pass in a theme like this, access it inside the header by using props.theme. So we don't have to do all that, since now they can directly access it as we provided using theme provider. So for the last part of this section, let's actually make use of it. We have our theme context and theme provider. Inside our main.jsx, we've wrapped our entire application inside it so that now we can access theme and toggle theme. So inside our header itself, first of all, to be able to access this context or this theme provider, what we need to do is we need to import it at the very top. So we need to import useContext. So we need to be able to use context from React. Then we need to import the actual context that we want to use, which is theme context from themecontext.jsx. After we've imported both of these, inside our header, we can access these two properties. So we can access our theme and we can access our toggle theme from inside theme by using context theme context. Okay, see what we did here. We imported a hook, used context that allows us to use context. So that allows us to access these values. And then we imported the actual context that we want to use. So this is the context that we want to use. We have to import use context only once. If we have like a theme context and you have auth context and stuff like that, so you'd have multiple context imported and you would do use context on them individually. So we use the theme context, which provides us with our theme and our toggle theme. And we can only use this because header lives inside app and app lives inside this theme provider. And remember, we created the theme provider right here. Okay, but now we can access the theme and toggle theme. What we want to do is we want to add a button inside here. I want to add a button that can toggle theme. So inside the button, I'm going to say switch theme to, and inside it, I'm going to insert JavaScript. So if theme, again, I'm just simply going to copy this. So I'm going to copy this logic and I'm going to paste it here. And I'm going to say mode at the very end. So what it's going to do is whatever theme it is, it's going to show the reverse of that. So if theme is dark, it's going to show light. If theme is light, then it's going to show dark. So switch theme to dark mode will be shown when the theme is light mode. Switch theme to light mode is going to be shown when the theme is dark mode. Okay. And to make this button actually work, you need to add an onClick event. On click, all I want to do is we have a function right here. This function is this right here, which is going to toggle the theme. So all I'm going to do is I'm going to onClick toggle. That is all I'm going to do. I'm going to call this function called toggle theme. So let's head on to our page. And one thing that we should see at this point is that this text is going to change, because as soon as we toggle theme, this will return false. And if we toggle theme again, this will return true. So it's going to show light or dark depending on the theme that we have. It's going to show the opposite one. So let me open up my Chrome again. And inside Chrome, I'm going to open up that page. And we can see it says switch theme to light mode, which means currently this condition is true. So it's showing light. If we click it, then theme should turn to light. And this condition will be false and we'll see dark. So as you can see, we're switching theme between light and dark mode. It's just that we have no CSS to reflect it yet.
which we're going to do right now. So inside our app.jsx, we're going to import the same two things. We're going to import useContext and theme context. So inside my app at the very top, I'm going to import the theme context, and we already have useContext in our app. Great. What I'm going to do is inside my app itself, all I need is the theme. I don't need to be able to change the theme from inside my app. So I'm just going to grab the theme, and I'm going to const theme, and I'm going to grab it from useContext, and our context is theme context. So you can see theme context provides us with theme and toggle theme, but you can choose what to import. So inside app, I'm never going to change the theme. So I just want the theme only. But inside header, I want to be able to change it. So I'm importing toggle theme as well. Okay, once we have the theme itself, inside my main div, so inside the main div that I have right here, I want to apply this theme by doing class name equals to app, and I'm going to insert the theme. So it's basically going to say app dark or app light. If it's app dark, then the class assigned will be app dark. If it's app light, then the class assigned will be app light. Okay? And inside our CSS itself, I'm going to add the CSS for those both. So inside we have app, deck, card, category, question, and answer. And at the very end, I'm going to add a few lines that adds theme. So I have these two lines of CSS right here. One is for app light. One is for app light.card. Okay, if I go to my page and if I refresh this, dark theme should be the same. I haven't changed anything inside the dark theme. So let me refresh that once. But if I change it to light theme, then you can see the cards change. Now you can add your own dark theme as well, since actually inside our app.jsx, what we're doing is we're doing app theme. So it's either going to be app dark or app light. So if we open up our elements right here and we open up this div, we can see that the class applied is app light. If we click on this, the class gets changed to app dark. So if you had a different styling for app dark, you could do that. And you can see that we're simply changing that class name by clicking on this button. Now the overall flow again, overall flow again was that we created a theme context and a theme provider. Then inside our header, what we did was we imported the context itself. We use the context by pulling out stuff from inside it. We can do this because our header is inside app, which is covered or wrapped around this theme provider. We can change the value of this theme, which is a useState, which is a state. So inside our theme context, we had a state for theme. Anyone can access this state by using theme and change it using setTheme. We're changing it using toggle theme. Toggle theme is basically just going to reverse whatever theme it is. We reverse it when we click this button. Inside our app.jsx, all we do is we import both of those contexts again. We're pulling out only theme from inside the context, and we're applying that theme to our element or to the entirety of our app by simply assigning a class name like so. So that inside here, when we click this button, you can see that the class name changes because it's pulling it from the state which is provided to it by the theme context. You can now share data across your entire application without prop drilling, and is one of the most useful skills in React to be able to send data from one component to other and access it in such a way. I hope that you practice this, go over this section a few more times because I know this was a tough one. And in the next chapter, when you're ready, we will tackle more complex state with useReducer and finally build our quiz mode, which I'll see you in chapter 11 for. Okay, so the idea of this section is pretty simple. Right now, we want to implement a quizzing feature. So what I want to write at the very beginning is a quiz. And generally in a quiz, what happens is we're keeping track of two things. We're keeping track of two things. One is the current question. So current question 0, 1, 2, 3, and so on. And the second is the score. So the current score of the player is 0, 10, 20, whatever happens. So generally, to use memory, up until now we've done use state to keep track of memory. So what we could do to keep track of these two things is we could make a use state for current and set current, and we could make a use state for score and set score. But there's a much simpler way to do this, and it is by using another hook called useReducer. So we're going to use useReducer, and instead of juggling separate use state pieces like this, we keep them in one state object, which is useReducer, and change it through actions. So that's basically what we're going to look at in this chapter, and it should be pretty straightforward. All right, so up to this point, I'm sorry if there's a little bit of background noise outside. It's raining right now, but up to this point, right, we've been using stuff like this. We've been using the hook called useState to store our question, to store our answer, basically to store anything in memory. We're using useState, and you know why we use them instead of variables at this point. Okay, but at the bottom right here, let me write something. When several values change, so when several values change on every action, lots of separate use state have to be followed, right? Because imagine clicking on a question on a quiz, so you must move on to the next question. So your question count also increases, and if you get it right, then your score should also increase. So both of those things happen at the same time. So when two things like that happen at the same time, they're hard to keep track of if we're just using useState. useReducer, the alternative, keeps related states, so related state like your score and question, in one object and updates it through something that we call named actions. So our logic, essentially, what happens when we do this lives in one place. So what happens if we get a correct question or if we get a correct answer? We get the next question and we get score. So those are two things that change at the same time. So for our case, our quiz state is current. So this is the question number, you could say the question number, and our score. We have our score, right? Both of these change on every answer, and we will use useReducer to achieve this. Okay? So for our quiz feature on our application, I'll create a new file, and this file is going to be named new JSX file. It's going to be named quiz. I'll just name it quiz for now. Inside it, there's a few things that I need to say. A reducer is a term that you will hear. It's basically a function. It's a function that takes current state and current action, or you could just say action. An action is basically a message. It's a message describing what happened. It's a function that takes current state of something, so maybe the current score, the current question, and an action, a messaging describing what happened. We moved on, we clicked a button, an action, okay? And it returns a new state. And dispatch is another keyword, is how we send an action, okay? For example, dispatch is going to send an action called correct to reducer. Reducer takes that action, so reducer takes in the answer, which is the state. It takes in the action given by dispatch, and then, for example, it increases score. Something like this would happen. A dispatcher or a dispatch is how we send any action that we want to. A reducer is the person who receives that action and has a state. A state is passed and the action is passed. Based on the state and action, we're going to change something.
we might increase, instead of answer, this should be score. So we might increase the score, which is one of the outcomes. So the outcomes will always return a new state. So state is always changed. Okay, let's look at it. First of all, as always, we have to import the hooks. So you have to import useReducer and useState from React. Okay. And we need an initial state. So you see our reducer takes in a state and an action. We need an initial state. So initial state is we have current 0. So this is the current question, and score 0. So you can see how we can define state in one statement itself. If we used use state, we'd have to do something like const current set current equals to use state and set it to 0, and then do the same for score. So we would have to do something like this if we used use state, right? We'd have to keep track of these two memory locations differently. But instead of doing that, we simply just we make an object initial state that has both of those properties, okay? After that, we're going to create the reducer itself. So remember, reducer is a function. It is a function that takes the current state, so either of these current states, and it takes an action that is given to it by dispatch. So reducer is going to be a function, for example, quiz reducer. It is a function that takes in a state and it takes in an action, and it's going to return a changed version of this state. So we're going to do a switch case. So you can either do this, you can do if action.type equals to answer, something like this. So you can do if statements and chain it like this, but instead of using if statements, we will switch. So we'll switch on action.type. All of these actions, so the action that is provided to us, action will have a type, okay? And we're switching on that. So if the type is case answer, so if action.type equals to answer, then what we want to do is we want to return that current is state.current plus 1, and score is action.correct. So is the action correct? If the action type is answer, so if the user has submitted an answer, we're checking if action.correct. If it is action.correct, if this is true, then we do state.score plus 1. Else, we just return state.score. And that is our object. So the object that went in would likely be current and score like this. And the object that came out would be, no matter what, the current question is going to get updated. So we're going to the next question number. But score, if action.correct, so if the answer was true, then the score increases. Otherwise, it doesn't increase. And we'll look at what this action object actually is when we pass it from the dispatcher. Okay? Next, another case could be, well, it could be anything, but in our case, I'm going to put another case called restart. So not react, restart. So it's going to return initial state. And all this does is it resets everything. So since initial state was current 0 and score 0, it's simply just going to return initial state, as in it is going to reset all the values to 0 if we restart the game. Okay? And lastly, we need a default case. Default means if none of the cases match, it's like a safety measure. We're just going to return state. If none of these cases match, then we'll just return exactly what we received. We won't change anything. We'll just return the same state. Okay, so there's three things happening here. Our reducer takes a state and an action. We're going to check the type of that action. If the type is answer, that means if the user has answered. We're going to increase the question number because we go to the next question. And we set a score if the answer was correct. If the answer wasn't correct, we just return the same score. If the user's action.type was restart, then we simply return a reset value. So we reset all of the score and the question number. else we just return whatever we got in. So read the reducer like a rule book. If the action is answer, move on to the next question and add to the score if correct. Every way the state can change lives right here in one readable place. That is the advantage of using reducers. Everything that you need to change, every single thing that you need to change, you have it right here. Now let's hook it inside a component and see how it works. So right below the reducer, I'm actually going to create a component. So the quiz component is going to live right inside here. A component is simply a function, and it's going to take an object, cards. Okay, quiz needs cards, obviously. And inside this, I'm going to do state dispatch, state and dispatch, and this is useReducer. Quiz reducer, the reducer that we're using is quiz reducer, and the initial state is this. So the initial state is current and score. These are the two state variables that we need to remember. We used useReducer. The first thing that you need to pass is the reducer itself. So all of the logic, we have all of our logic in here. Second is the initial state. Initial state is basically an object of all the states that we want to remember. And in turn, it gives us a state and it gives us a dispatch. State, we can check what we have inside this particular hook by using state. So maybe after this, if we check state, our question number would have increased. And if we got a right answer, our score would have increased. So we can see that change inside state. Okay, I'm going to check something else. If so, a small bit of UI of local UI state. All I want to do is I want to show answer and set show answer. So again, I'm still using use state, and by default it is false. So even if you're using useReducer, you use useReducer to group together states that you need to change at the same time. Whereas show answer is not really something that you need to do at the same time as answer a question, right? You can click on show answer and it will show you the answer, which is like a UI state. You can click on it, or after you get a question right or wrong, it'll show you the answer, which can simply just be a UI state that we use useState for instead of using reducer. Next check, if we've gone past the last card, the quiz is over. So we have a bunch of cards. If we've finished all of the cards, so if we're at the last card, the quiz is over. So if state.current is greater than cards.length, then we're going to return an h2 tag. Actually, we're going to return a div because we have returned a single element. So div, this div is going to have the class name quiz for now. I'll define that later on. And it's going to have a h2 tag that's going to say quiz complete. And maybe in the next line, we print out the score, right? So you scored state.score. You can see that state right here. In this case, state is the object that has everything inside it. State has state.current, so state.current right here, and state has score. So state.score, both of these can be accessed from right here. If we did it using useState, we'd have to access current and score separately, but they wouldn't be in the same object. They would be a separate state on their own. So you'd use current, set current, and score, set score. But we're doing it at the same time right now. Okay, and then next I'm going to add a button. And this button is simply just going to say play again. And what I want to do is if somebody clicks on this button, on click, I want to run a function that is going to do a few things. So first of all, if we click play again, we need to reset the game, and we actually have logic for resetting the game right here. It's case restart. Now remember, how do we actually call the reducer? To call the reducer, we need dispatch. Dispatch is how we send this action. We have this state by default, but we need this action, and this action only dispatcher can give. So we have to call dispatch. So the way you do that is you simply just type dispatch, and you say type, and the type is going to be restart. So this is the action. This is the actual action that is passed on to our quiz reducer. And the action, we're checking action.type, right? So since this is the action and the dot type has restart inside it, it's going to execute whatever's inside restart. So it's going to return initial state. It's going to reset the initial state. Next, we also need to do one other thing, that is set show answer to false. So in case we were showing answers before, we don't want to show answers anymore because the player has just clicked reset and we shouldn't be able to see the answers. Okay? But now we have cards. We actually haven't defined what cards are yet. We have cards at the top right here, but we actually haven't defined it. But before you do that, const card equals to cards state.current. So cards is an object with all of our quiz cards inside it. And we're accessing it using index. For example, if we had a object like this, and then the first question, for example, the first question was, it had a question, it had a question, and the question was hello, and we similarly had an answer, and the answer was hi, and we had a bunch of objects like this at the same time. So like this, like so. It's going to give me error right now because this is not formatted properly, but this is our object, right? If this object was called cards, to access this element or to access this specific object inside it, what would I do? I would simply just do cards and I would give it its index. So this is index 1 and this is index 2. So I would access the second index of this cards, or like so. And I think this needs to actually be an array instead of an object like so. So this is actually an array. So inside this array, we have a bunch of objects like this. And obviously, the indexing starts from 0. So this is the 0, this is the 2, this is the 1, this is the 2, and so on and so forth. So similarly like that, all we're doing is we're doing cards state.current. So we're accessing the current question we are on. So pass the current question. By default, it is 0. 0 would give us the first question, 1 would give us the second question, and so on. And card would give us the specific card for that question. That card will have the question and the answer and everything else that we need. So all in all, useReducer, what you have to understand, take away from this section is that useReducer gives back two things. One is the state and one is the dispatch. State is where the actions are gone. It is the read it. You can read the state. You can know what is inside the state. And dispatch is what we use to send actions with. So to send actions to quiz reducer, we use dispatch. When we use dispatch right here, we send an action and a state to this quiz reducer. We also derive is the quiz complete by simply doing a simple check like this. All we're checking is if current has passed the last card so that no extra state is needed. Now let's let the player reveal the answer and grade themselves. What I'm going to do after const card right here is I'm going to create a simple function called answer, and it's going to take if the answer was correct or not. Inside it, we're going to use dispatch, and dispatch is going to dispatch that answer. So type is going to be answer, correct is going to be correct. Okay, so we're going to dispatch this and we're going to set show answer to false right after. So this function, we're going to call it every time the user gives us an answer. We're going to know if that answer is correct or incorrect. So if the answer was incorrect, dispatch is going to call our reducer with this object. It's going to say type is answer and correct is false. We're going to pass false. If it's true, it's going to call type is answer and correct is true. And over here, all we're checking is we're checking action.correct. If it is correct, if it is true, we add a score. If it is not true, we increase the current question, but we keep the same score. And that is the logic and how it ties in. So after that, we're going to return. And finally, So we're going to, this only occurs, by the way, this is only returned if the quiz is over. So if this condition isn't true, none of this is returned. So by default, we need something to return, right? So we're going to return a div, and this div is going to be of the class name. It is going to have quiz, okay? And inside it, I'm going to have a paragraph tag. So question number, and let's say the question number is state.current. But if you say state.current, then by default, the question number is 0, right? Because by default, it is 0. So we'll say +1. So if the index is 1, the question number is going to be 2. If the index is 3, the question number is going to be 4, so on and so forth. I'm pretty sure you're familiar with indexing at this point. Question number dash of cards.length. So this is the total number of questions that we have, or the total number of cards that we have. Then we can also show the score. So we can say score is state.score, since that is also stored inside our state. Then in the next place, we can have a heading. And in the heading, we can simply give the question. So card.question. We're going to make all of the cards, don't worry about it. And what we want to do is we're going to add a button that shows the answer. The way we do that is if it's not showing the answer currently, if it is by default not showing the answer, and so we show a button. So we show a button, and this button on click is simply just going to set show answer to true. And inside this button, I'll just say show answer. So if you're currently not showing answer, then this element is going to get rendered. When we click on this button, we set show answer to true. So now we're showing answer, and this button simply has the name show answer itself. Okay, after showing the answer, so show answer, if we've shown the answer, then what we do is I'm going to create an empty element right here. And inside it, I'm going to have a paragraph tag with the class name of answer. So this is the actual answer, card.answer. And at the end, we can have a button and 2 buttons actually, on click. And this button also has an on click. Just bear with me for now, for a little bit. I got it right, and I got it wrong. This button is going to set the answer to true. So it's going to set the answer to true. And this button is going to set the answer to false. And we can see that we've defined answer right here. Okay, what's happening right here? By default, we have our question number out of how many questions and our score. Next, we have the card question that gets displayed on h2 tag. Right after that, if we're not showing answer, so if the player has not selected show answer yet, we want to show them a button that says show answer. Once they click that button, this will be true, and we'll render this element, and inside this element, we simply have the answer of the card, and we have 2 options. One option says I got it right, one option says I got it wrong. So whatever the user presses, they get it right or wrong. Now, I know it's not really intuitive for doing in a general sense of quiz, because the player can always lie, but we're assuming that you created this application to help yourself study, so I'm assuming you'll be honest with yourself. So if they click the I got it right button, the answer is going to be called with the true parameter or the true argument, and we're going to call dispatch and send correct as true and set show answer as false. If we send in false, then we call the dispatcher with the type answer and correct equals to false, which in turn will give us false from our reducer. So our score won't increase, but our question number will. We can temporarily try this. So this was a lot of theory only, not much practical in this section, but we can temporarily try this by putting it into our app.jsx. So what we can do is we can export this function. So export default quiz. We can export quiz. And inside app.jsx, we can import it. So we can import quiz, not like this, import quiz from quiz.jsx. And
right here inside the return, right below our deck. So right below our deck, I want to add our quiz component. So quiz cards is going to be card. So we pass in cards as a prop, and we accept that card as a prop right here. And we're using these cards, so like we can access the card's length, we can access the different indexes of that card, and so on and so forth. Okay, and inside our app, that is all that we need to do. Now let's save this and let's start up a server. And right here, if you go a little bit down, you can see quiz number 1 of score, or 1 of 50, and the score is 0. How many sides does the heptagon have? 7. I'm assuming 7. So you click on show answer, and then it shows you the correct answer. And then you can either press I got it right or I got it wrong. If you press I got it wrong, then this question number will update, but the score won't. If you press I got it right, the question number and the score both are going to update. So if you press I got it right, we moved on to the next question and we got a score. Now, if I click on show answers, I have no idea. Kenya, Ethiopia. So I got that wrong. So if I press on I got it wrong, it's going to proceed to question number 3, but my score is still going to remain 1. And you can see that the questions are simply just looping over what we already have right here. So this was questions 1, 2, 3, 4, 5, 6, and so on. So like in that manner, this will also loop through all of those questions. And the neat thing is that we didn't have to make a separate API call for the cards because we already had a hook that did it for us. You remember our use cards hook. So our use cards hook already gave us the cards. So we can use the same cards to create our quiz. The flow, what happens is you click a grade. Whenever you click a grade, your dispatcher is actually sending an answer action. The reducer makes it a new state. So reducer maybe changes the current question or maybe changes the current score. And React is going to redraw this entire component. Every rule of the entire quiz will live inside this one reducer function. That's why it scales so well. The logic isn't scattered, it's in one easy rule book. Pause. In the results screen right here, what I want you to do is I want you to add a conditional statement that looks something like this. Not exactly this, but if you get a perfect score, that means your state.score is perfectly equal to your cards.length. I want you to print out a paragraph that says perfect score and like a celebratory emoji or something. Okay. And the last thing that we can check right here is if we click on reset. Okay, we didn't really have a reset button. So the reset button or the play again button appears when we complete the score, complete the quiz. So one thing we can do is let's try to go to our use cards. And inside use cards, instead of pulling in 50 different questions, let me just pull in 5 different questions. So let's refresh this. It's going to pull in 5 questions. And if I keep on clicking show answer, I got it right, show answer, I got it wrong, show answer, I got it right, I got it wrong. And this is the last question. And I click on I got it wrong. It says quiz complete, you scored 2. And you can click on play again, and you can see that the question gets reset and our score also gets reset. You can also add, instead of just saying your score is 2, you can say your score is 2 out of how many there were in total. So we can do that right here. So you scored state score. Instead of saying that, you scored state.score out of cards.length. So if you do that, then if you come to our page and refresh it, and if you click on show answer, and I keep clicking on I got it right, maybe a few wrong, it's going to say you scored 3 out of 5 and quiz complete. So pretty neat. We did all of that using useReducer, and simply these both states, so the question state, question number state, and the score state both lived inside the same object by using useReducer. All right, so the thing that we want to achieve in our final chapter is pretty simple. It's called React Router. It's a pretty huge topic and it's pretty important, but its function is actually quite simple. Right now we have our quiz, plus we have our flashcards in the same page, right? We have our flashcards on top and quiz on the bottom. Generally, apps don't work like this. So what we want to do is your URL /quiz
quiz is going to run it in your quiz, and slash cards or slash cards, something like this, is going to load a different page. So this will have only our quiz component, and this is going to have only our flashcard component. And we're going to achieve that using React Router. Before we start, let's go into our app.jsx and React. Okay, so React always builds single page applications. The browser itself loads once, then JavaScript swaps the content. That's all that's happening. We've seen this before, we've looked at this before. The root, everything inside the root is swapped using JavaScript. Okay? Routing is how we show different pages for different URLs. So you might have /API, /health, you might have /login, /register. So all of these different pages that look different. So we do this without a real reload. We don't have to actually reload this. So the standard tool that we use for this is called React Router, which makes routing possible. So what we're doing is we're turning our one screen app into two clean pages. One is going to be deck, the other one is going to be quiz. So this might be pretty short. All you need to do is open up your terminal. I've already done it here. And close your development server first of all. Right after you close your development server, I want you to run npm install React Router DOM. So this is a package that allows us to use the React Router. Then close out of it and open your main.jsx. The first thing I want you to do is import it. So you want to import browser router from React Router DOM. The next thing is whatever you want this router to access. So whatever pages that you want to route with this router have to be surrounded by this router. So right inside here, look at how we've wrapped our app component or our app page inside our theme provider. Like so, I'm going to wrap this theme provider with my browser router like so. So now my browser router lives at the outermost of theme provider and outermost of app. Forget strict mode for now. So it switches on routing for everything inside it. Everything inside it, it switches on it. We wrap it around our entire application like we did with theme provider. Now let's split our screen into two real pages. A page is basically just a normal component that we show for a URL. We just show a different component for different URLs. Let's move our deck. So inside our app, let's move our entire deck into its own page. So inside source, I'm going to create a new JSX file, and I'm going to call it a deck page. Inside deck page, I'm going to move everything outside of app that we used. So the first thing is this useState, useEffect, useReference. I need this. Second thing is I need the actual flashcard. So I'm going to put the flashcard in here. I'm going to create a function called deck page. And this function is going to take a few props. It's going to take cards. It's going to take set cards. It's going to take loading, and it's going to take error. So this will be provided to us from the app itself. Next, we have, let's say, question and answer. I wonder where those are. So we have our question and we have our answer. So we need these things, and we can put them into the deck page itself, right? What else do we need? You can take the useEffect. So we can grab the useEffect and we can put it into our page right here. Next thing, our add card event. So everything that has to do with adding cards, we can put this entire thing in here as well. And finally, our entire div. So our form, our buttons and everything. So this entire return statement right here can also go inside our deck page so that we can clean this up a little bit. So let's pull all of this actually first. Let's copy it over to our deck. And I want to remove this quiz cards section. And let me remove this. And everything in here should be working. And for now, I'll just put a return statement in here that is just empty. So I'll just put an empty return statement right here with just an empty element like so. Everything should be fine. So we've basically just moved all of our logic into our deck page itself. So let's see if we have everything. So we have our question, we have our answer. We actually don't have our question input, so we didn't grab this. We need to grab this out of here and place it in here. Create an empty reference so that we can select the pointer as soon as we load the page. We have our useEffect to do the same thing. Then we have our add card event so that we can create a new card. Everything looks fine. Then we're returning this. We need theme right here, so we don't have access to theme. To get access to theme, we have to actually use context. So I can simply just grab this. We can leave it in app.jsx as well, but I'll grab it out of there and I'll grab the theme right there. Use context, that should be fine. The theme context itself is probably not imported, so I'll import this as well. I'll import that right there as well. Now let's look for anything else that we didn't get. Everything else seems to be fine. We should have gotten everything else. Okay, so now we're going to create our quiz page. So our deck page is done. We're going to create our quiz page. We're just separating our logic into different pages. So inside quiz page, we need the actual quiz. So import quiz. Then of course you need the function. So quiz page, and it's going to take props of cards. And inside it, simply just I'll write a simple logic if cards.length equals to 0, then simply return a paragraph saying loading cards, else return our quiz. So the quiz cards that we already made with cards passed in as props again. At the end, we need to export default quiz page. So our quiz page is done. Our quiz leads us to quiz.jsx, which takes in cards as a prop and then works with that. This prop is given to us from somewhere else itself. Okay, so we have two tidy components. We have two tidy pages. I'm sure if you've paid enough attention and gone through this one by one, hands-on training, I'm sure you're familiar with everything that we copied over and you're clear on what everything does, how everything ties into each other. Now the app becomes the shell that decides what page to show. So this is just the shell that decides what page to show next. So we need to do three things inside our app.jsx. First of all, before we even start, we need to import everything. So we have imported header right here. Next, we need to import our deck page from deck page. Did I not export it? It seems like I didn't export it. So export default deck page. And then we need to import our quiz. So I'll put the quiz import up here. So we imported the three components. Header is going to be on all of the pages, or header, we're just going to put it on the deck page. And then we have quiz for quiz page. So not just quiz. I don't think it's quiz. We need to import the quiz page. So import quiz page from quiz page. Then we have our use cards. We also need our use context. We have our use cards. We need our use context. So use context from React. That should be fine. And we're also going to do some styling for final touches. So we're going to import app.css. Finally, for routing, we're going to import routes, route, and link. So these are the three things that I want to talk about. We're going to import this from React. And we're going to use them and see how they look like. So at the very beginning, we have our shared deck. So I can remove this line. Let me add a comment right here. So this is our shared deck for quiz and deck page. So both of them are getting the same questions or the same deck. Next, we're grabbing the theme, so that should be fine. Okay, so in the portion where we're returning, well, we're returning a div. and the div is going to have the class name of, simply like we did before, app theme. Needs to have that theme. Then inside it, I'm going to add a link. So a link tag like this, and it's going to say to equals to slash. So if it's home slash, then it's going to go to deck. If it is on slash quiz, then it's going to go to quiz. Simple as that. Next, we need to have our routes. So we can have our routes in here by simply creating routes like so. And inside here, we can have individual route. So we can have one route. The path is just slash. Our element is deck page, cards equals to cards. We're just passing in all of the props now. So set cards equals to set cards, loading equals to loading, error equals to error. Like so, and we close up that element, and we close up that element. So in our route, so in our slash route, we're going to load in the deck page, okay? When we load in the deck page, we're going to pass cards, set cards, loading, and error as props because that is what deck page requires. It requires cards, set cards, loading, and error as props. Similarly, we need a different route. So we need another route. This route is going to be for the path slash quiz. And all it requires is, well, we actually need the quiz page. And all quiz page requires is cards. I don't think it requires anything else. So we can safely close this up and close that up right there. And at the end, we make sure that we have export default app. Okay. We're going to add a little bit of styling to this as well. I want to add some style. So what I can do is at the top, oops, I forgot header. So I need header at the top. And right after that, I'm going to wrap these in a nav element with the class name of nav. So we're basically returning a div, and the div has the app theme. At the first, we have a header. Then we have a nav bar. Inside it, we have two links. So the first link takes us to deck. The second link takes us to quiz. If we go on the slash route, so even if you put it in the browser URL, if you go to the slash route, then we load in the deck page, so this component, with all of these props. If you go into the slash quiz route, we load this component with all of these props. So pretty simple, right? These actually don't render the page itself. They just tell you where to go. If you press on deck, you'll go to slash, and if you press on quiz, you'll go to slash quiz. Let me add a little bit of styling first. So let me go into app.css. And inside my app.css, we can actually remove all of this. And I can paste some styling for my nav bar. Now, if I start the development server, by default, if I go to this page, so if I open up Chrome and I go to this page, okay, so right here, we're getting an error. Element type is invalid, expected a string. That is because I looked through this. So we're actually importing routes, route, and link from React, whereas it should be React, router, DOM. So then all of these imports should work properly now. And if you refresh our page, so you can see this is my header section. So let me try refreshing. All right, this is my header section. So we can switch the theme to dark and light mode right here as well. So this is rendering twice. I wonder why it's rendering twice. I can go into my deck page. I think I might have put in a header here. Okay, I put in a header on my deck page as well. So if I remove that, okay, my deck page loads just once, and I can click on deck and quiz. So when I click on quiz, the header stays the same, but I get my quiz part. So I go to slash quiz. If I click on deck, I get my deck part. So I go to just the default slash route. So I can switch between different pages like so, while still maintaining the same header. So switching between different pages is just the difference of showing different kinds of components on the screen. It's not necessarily a completely different application or a completely different page. It's just showing different components on the screen. So let me go ahead and put some quick CSS some basic styling into this application real quick, and I'll come to you with the final touches. Okay, so for the finishing touches, all I did was I edited app.css a little bit, and then I edited index.css a little bit, and I used these styling already imported into my deck page, my quiz page, and all. So I haven't actually changed anything inside here. So I haven't changed any of the code inside here. Everything that you did perfectly works. I've just put some styling over it just to make it a little bit nice. So of course, I'll upload this to our GitHub organization where you can easily access all of the source code, download it, and use it and see for yourself. But this was our entire application, and the finished application looks something like this. So you have your header section divided by a line. You have all of your questions, all of your cards. So if you refresh, by default, you select the question by default. You can add a question, answer, you can add cards. You can hover over a card, you can click on it to show whatever the answer for that was. You can clear your cards. You can refresh, it'll show up. You can click on deck, which will show the same thing. You can click on quiz, which starts showing you the quiz. So I got it right, I got it wrong. You can see your scores. And at the very end, it does show your score as well. Quiz complete. You can click on play again. And all of this completely incorporates React, components, props, state, lists, forms, fetching, custom hooks and references, context, useReducer, and routing. So look back at what you built. A real app with loaded data, a form to add cards, flippable cards, a theme switch, a self-graded quiz, and multiple pages. And you understand every single line. Well, at least you should. Run through the whole app once on the screen, load theme, add card, flip it, take the quiz, and see your score. You now know the core of React, genuinely enough to build real things. From the next level, managing big app state with Redux, going full stack with Next.js, adding TypeScript for safety, testing, and smooth animations, each one gets its own video if you'd like. So let me know what video you want to see, links on the screen and in the description. Subscribe so you catch them. Try everything in the Codin playgrounds we have over at codin.com. Share what you build in our Discord, link down below, and I'll see you in the next one. Great work.